Is it okay right now?
Now it is.
Okay.
We had a... Nedošlo, že prerušovač.
Yeah, it's okay. We should have been here.
Fine.
Okay.
Já myslím, že takhle to je dobrý. Já to vidím, že si to víš, tady a... Sure. Okay. Sorry, I thought you said that. Sorry, I thought you were check. Jo, jedno nebo druhý. Yeah, okay. Jo, dobře. Teď to byli to příče. Jo. So, until it goes yellow, we're fine. Until it goes red, it's fine. Yeah, if it gets... Potřebuješ ještě něco, nějakou cokoliv, když začneme?
Asi no.
Jo, já myslím, že to tam... Jo, máme ten opt-out, tady ten formulář. Nevadí ti, že budeš zaznamenávaný, že jo? Ne, okay. My jsme měli teda ještě opt-out formulář pro přednášící, jestli jako nedílí, podobně ten.
Jo, to asi.
Tak jo. Budeš? Můžu se sám nechat bude.
Tak něco můžeš uvést.
Okay, so good morning, everyone. Oh, ow.
Jasně.
So good morning, everyone. Welcome to the second day of this year's DevConf. I would like to welcome our today's first speaker in this room, Martin Drachar, a researcher at Masaryk University, who will take us to the long road to autonomous security. There will be a few minutes at the end of the session reserved for your questions. So enjoy, and without any further delay, I'm giving the floor to the speaker.
Okay. Thank you. Hello. If you hadn't been living under the rocks for past few years, you probably noticed that the age of AI is upon us. It's almost everywhere. I mean, we have driverless cars, driverless taxis, trains are running themselves, oftentimes better than normal drivers. We also have tools that are able to produce art, or at least pretty pictures, and also these Lovecraftian horrors on the other side. We also have language models and chatbots that are able to pass the Turing test, that are able to converse with people, that are able to create essays, to summarize text, and all the other fancy stuff. And it's natural to ask what is the state of the AI in cybersecurity? I mean, where we are on this scale of two homicidal artificial maniacs. And this largely depends on who you are asking. If you ask the companies that are selling AI-powered systems for cybersecurity, yeah, they will tell you they're swiftly approaching the shot-on level of capabilities. If you ask anybody else, mostly the researchers in this area, you'll probably get the answer that even the Roomba is overselling our current capabilities. And what's the reason for that? I mean, just a few numbers to begin with. The Tesla, their new beta driverless mode has driven more than 250 million kilometers. And every time something happens, just upload it to the servers and it used to refine their models. Stable Diffusion is producing those pretty pictures. Yeah, they used 160 million images to train their model. GPT-3, the obsolete one right now, has used 45 terabytes of text data to train and produce the model. What do we have in security? Well, mostly limited data sets. It was not so long ago, time that for about 10 years, for training machine learning powered systems, we were all using the same old obsolete data sets. And the situation really hasn't changed that much because there's not enough data sets and they're not, let's say, variable enough. They do not cover all the use cases that we want to focus on, and they don't really reflect the real world situation. And also, we don't really have the environments where to train those autonomous cybersecurity agents. So the situation is in a way quite bad, but as I assume most of you here are developers, so what is the natural reaction? Do something about it. Create some environment where you can train those agents, where you can work on that cybersecurity. But there's a good reason why the state of these tools and of let's say cybersecurity autonomy is where it is, and it's because it's not a really easy problem. So for starters, if you want to create an environment where you want to train something, you first have to decide, let's say, which paradigm to use. Will you just simulate everything? Will you be using, say, Docker containers, where you use fully virtualized networks and so on, or some hybrid approach? And going back to those large numbers a few slides ago, just imagine that you want to do hundreds and thousands and millions of different scenarios that you want to play out. And you suddenly realize that you really can't work with virtualized environments because you don't have the hardware and power to run so many different scenarios to restart all these different scenarios and prepare the hardware. Also, you usually don't have all those vulnerable machines that you want to try and so on. So it's a problem to get all the stuff that you need. And even in emulation, you just hit the same brick wall. You just can't run it all. So the only way to, say, prepare the environment for training autonomous cybersecurity tools is to have some kind of simulation environment. So does any one of you recognize some of these pictures? Yeah, I see some heads nodding. The reason I'm showing is that these are OpenAI gym environments that are used for training machine learning algorithms. The problem is that you can't really use them for cybersecurity. I mean, this is not how you secure your network. And this is the problem, that all those environments that are available are just simple abstract problems that just, they don't reflect what the cybersecurity is about, how everything is connected, intertwined, the domain is really large. And this is really, really hard stuff to come up with the environment that is able to reflect that, that complexity. But let's say you you somehow get your hands on that type of environment, that you have an environment where you can train it, where the environment reflects the complexity of the domain, and that you can simulate everything you need. Let's just, for the sake of the argument, say that you have this. Is it all that you need for training autonomous agents, or having working autonomous cybersecurity agents? And the answer is not really. I mean, this is just a high-level description of all the problems that probably needs to be solved before we can even think about letting autonomous cybersecurity agents loose. And some of these stuff may not be applicable to, let's say, normal domain that this was done for the army, but most of it is valid even for civilian context. So, but one step at a time. And in this talk, I want to just guide you or present you the decisions that one has to make when deciding what to do when you want to create a simulation environment and that you want to use for training autonomous cybersecurity agents that will be usable. So not something that's, let's say, just doing some abstract stuff, but something that can later be deployed and used in a real world context. So it starts with, let's say, one easier decision, that it's to choose what modeling approach we'll use, whether it be some kind of discrete event simulation, Markov processes, game theory. This is actually one of the few questions that is not really that important, because you can probably get away with anything. The harder part is choosing the abstraction that you want to use. And so, for example, I'll start with network modeling. Like, let's say that you want to create an autonomous agent that will be able to somehow guard or attack, this doesn't really matter, some kind of network. Then you probably have to, in that environment, have some representation of that network. So yeah, it's just network. What it is a collection of nodes that are, connected. There's some connections, but is this enough to decide what to do? You probably need to do some refinements. You have to say, okay, so there are two types of nodes. Like, we have something on the edge, and then we have network, active network devices. But on the edge, there are different types of machines. Like, you have workstations, you have servers. You somehow need to account for that in the model. And how about the, let's say, IoT stuff? You have the cameras that are linked. You have some kind of printers. Printers are good vectors for attacks. But how about IoT devices? Laptops, mobile phones, whatnot. And all the stuff in the cloud. Will you account for that in the model? You have to, because it's just what it is right now. So when you want to model how the infrastructure looks on, let's say, the network level, you have to account for the current realities, and that's it's a bit complicated, and it needs to be detailed enough for that autonomous agent to decide, and to decide correctly. But let's say, okay, you decide on some kind of infrastructure. Good for you. Now it's another part. How do you model those nodes that are in the infrastructure? Will the type of the node, like the PC, phone, a printer, whatever, will be enough? Or will you have to include more? Like, what is the operating system running on it? What are the services running on it? And if you think about how different exploit looks like and how the tools that are using them to exploit this stuff, how they work, you'll probably need to give it something more to work with. So for some exploits, yeah, you will need to have at least some kind of model of the file system. You may need some model of memory. And for even some lower level of exploits, you may need modeling the communication between buses. It's your decision, and you always have to think about what the agent will do, what it will be capable to do. How about connections between those nodes? I mean, you can decide on a medium whether you will be simulating that there's a difference between, for example, going over the air, over the wire. Will you be modeling the properties, like the bandwidth of the connections? That's needed if you want your agent to, for example, be able to work with DOS attacks, because then you need to model that how the connection looks like. And how about protocols? There are many different attacks on protocols that are abusing their structure or whatnot, so you probably need to include that, or not. It really depends what you expect your agent to do. And how about the users? It's another kind of worm. I mean, do you even want to have users in your simulations? Or do you just say, okay, let's say there are no users and we're just securing the infrastructure or attacking? But if you decided you want to have users, will there be just some kind of user types, or will they have different identities that are, for example, linked to different data on those nodes? Are the users active? Are they doing something, or are they just reacting to, let's say, external stimuli? Do they produce some traffic? And even, are they just working 8 hours a day? Do you want to just model their behavior as the day goes on? There's really hundreds of considerations that you have to do. And each of these considerations will affect what the agent will be able to do. And we'll talk in both attackers and defenders. Because if you don't model something, then the agent is not able to react on it or act on it. So yeah, hundreds of considerations, and what I described right now is still just only the passive side. You're describing what is the environment where it happens. But when you're trying to create a simulation that's workable, you also need to think about the active side. You need to think about what the agents can do. So, for example, and I'm talking right now about attackers. How do you model that the attacks unfold? I mean, for quite a long time, this was the default attack model that was considered in research publications. There is an attacker and there's a target. That's all. Something happens in between. Okay, then there was, let's say, DOS attacks or some attacks that require coordination. Okay, more attackers, one target, still nothing complicated. But then you have things like this. That's just a representation of what Stuxnet did. And you see that the attack path, and usually attack path of any APT or some more complex malware is much more complicated. So when you're considering how to model the attack, you just needed to enable it to do all this stuff if you want it to be able to act upon it and act reasonably. Which adds another layer of complexity, because when you give the actions to the agent that can do, they need to be expressible within that model. They need to have the impact, and the agent must be able to learn that impact. Again, there is something you need to incorporate in that model, because then, when you're implementing it, you need to be able to provide the correct outputs for agent's input. So what will you do? Will you just some kind of some kind of abstract actions, which is, for example, this is something that is currently mostly being done. That there are only few abstract actions, like say, okay, I'm scanning, or I don't know, I'm brute forcing, I'm exfiltrating keys, and that's all. But if you ever use those tools that are doing those attacks, the actions are usually much more complex. You have to set a lot of parameters for those actions to work. You can also use some kind of attack and defense taxonomies that are available, or you can use something of your own. This is just for illustration. These are attack and defense frameworks that done by Mitra that provide some kind of structure to possible attack and defense actions. There, it's just high level. There are also many different tactics that are linked to each of those categories. But yeah, if you want to simulate that, and if you decide you want to simulate it, then you just need to go through each of these sections, possibly each of those the techniques, and you need to implement how those techniques reflects in your model. So there's quite a lot of stuff that probably needs to be done, and you get this for free when you're having fully virtualized environment. But as I said earlier, you really can't do that because you don't have the hardware. So yeah, you're kind of stuck between a rock and a hard place with this. And I would just briefly introduce one of the simulation environments, one that I've developed or started development of. Currently a work of many people, and yeah, I never wanted to do this. I just wanted to produce the agents, but instead I spent a couple of years doing this, and it's been only recently that I got into the state that I can use it to train something usable. So that's the simulation environment. It's just one combination of all the possible parameters, all the possible decisions that I've described earlier. And it's a discrete event simulator that supports message passing. It's mostly used for simulation of lateral movement, which means that there is the infrastructure somehow simulated, and there are services simulated as running on those nodes. And there's not that many complexity. But it provides a rather comprehensive authentication authorization framework. It's working with vulnerabilities that have those on CVE sets tied to Metasploit and so on. So it's being done in a way that the agents trained on that simulation can be then moved to the real world. And yeah, it integrates with those different machine learning toolkits. It enables to use different behavioral models, so you can plug different behaviors or different actions that the agents can do, and then you can let's say compare how this works. And it even simulates or enables integration with stuff running outside the simulation, so that you don't need to re-implement everything in the simulation. So you can have your IDS or IPS running outside of it, and there's just a bridge between those two, that you can just take the messages that are running in the simulation, convert it to something that the IDS IPS understands, just let it process it and give you back the response. So it's just trying to reduce the effort that the user of the system needs to do. Why I'm saying it is because it's open source. You can try it, you can download it, you can play with it. Easiest way to find it is just to look at PyPy, and yeah, there's also a documentation. It's a research project, so the documentation is incomplete, as it usually is, but you can start doing something with that. We have a lot to, we have big plans with this, and the development still continues. A few things, just to name that we're working on is one that's tied to the unavailability of data sets, and that is we're building a mechanism that can create a realistic simulation, realistic scenarios, so that you just provide it with some constraints, what you want to have in this scenario. For example, yeah, I want to have this large infrastructure with some of those services or nodes running, and it will construct a vulnerable infrastructure that has some attack paths that runs through it, and then is able to instantiate it. And the other important thing is that we are working on transition from the simulation to emulation. So that means and this is one big problem in this area, that when you have the agent that trains on the simulation, you then need to somehow move it outside. And this transition is complicated, because in a simulation you're working with abstract actions. You try to move it to real world, and somehow this doesn't really transfer. In the real world, you have to use different tools. You have to give the agent the ability to affect the environment. So that's something that we're working on, and we have some working prototypes that the agent can just directly use what it's been training with or training on, and it just moved to real world. It still thinks that it's inside a simulation environment. Nothing changes for it, but it's doing a real world work on the outside. If this may be too long for you, and I understand it, because it's really at the beginnings, and you can, for example, want it to be, say, available as a service, that it can already create some scenarios that enables you to play with those agents, perhaps visual analytics or whatever, and maybe just only the big green button that does all the stuff. We're working on that too. It's just a sneak peek preview of what we're working on, and it's the AI Dojo project that we're doing as a collaboration between Maastricht University and ČVUT. And this is something that will be, this should be an integrated environment for development of those type of technologies with already pre-made agents that you can use. Something that, for example, if you want to train users with those agents, that they can collaborate with, or they can fight against each other, and provide you with all the analytics and all the control of that. But that's gonna take some time. So this is the current state. I'll wait a few years, then we'll have something, and maybe my presentation will be different at the time, or you can just try to code something and see where it gets you. And that's all for me for today. Thank you. questions.
You want to
So
go first?
What analytical models did you implement, or did you implement a single one? Do you see advantage in implementing multiple ones to get better results on the analytical side of the model?
We actually implemented multiple models, and what we learned was that those, and I'm thinking about talking about some kind of research model. There was some kind of taxonomy of attack actions, and it turned out that on the paper it sounded good, and when we tried to implement it, we just find a lot of edge cases where it was not working, it was not complete, it was overlapping. So yeah, we're still trying to find the good model that's comprehensive enough, but it's implementable in the simulation, and it translates well to the real world. So that's the situation.
So Microsoft has a
Cyber
AI
robotics, yeah.
security, Copilot or help thing. How does this relate to that? Is
There are people that are trying to use those language models to drive those agents, and it kind of sort of works. And usually those language models, they are noisy. They're producing outputs that sometimes works, sometimes does not. So if you use it, for example, to drive a penetration testing tool, it works in a way, because there's no problem with it, because even if you do wrong actions, nothing bad really happens. But in this situation, you don't want to use it as to drivers of the defense, because you can't really work with, let's say, 80% success rate. So yeah, people are using it, it produces some results, but I think going the last mile to have it, to use it as something that you can trust, that's going to take much longer time. But it's a possible approach.
What are the measures being applied or solutions to prevent the defense agents from being compromised?
That's a good action. That's a question. I'm not really sure. I mean, this really depends on the authors of the agents, if they prepare it somehow. This let's say beyond my domain.
I was actually wondering about that myself, and at the risk of exposing a lot of ignorance here, what I was worried about was after you have this, the simulation, things trained, when you're trying to protect something in the real world, does it have to know what it's protecting? In other words, understanding the configurations of all the machines and the open ports and you just everything else. And it seems to me the simplest way to gather that information is to have a privileged crawler or something like that can draw information from the different machines and find out about their configurations. But if it's doing that, it's on your network, and if that thing gets compromised,
that's a hard problem, and usually what's happening in the simulation world is that those agents are provided that global overview of the state, something that you described, and that's what they are being trained on. I mean, I'm not aware of somebody doing the defender that would take care of the whole infrastructure and does not have access to this. So, yeah, first time it gets compromised, it's gonna get ugly. But then, on the other hand, I'm working mostly on attackers, so I'm okay with that.
How many people are in your team or the whole project that's working on this?
That AI dojo, it's probably 10 people, something like that.
I was thinking if you had reached out to some, because I saw the disclaimer that they are funded by some European project, but have you tried securing some funding or support from some of the big companies that are certainly interested in this type of work?
Actually, not the big companies. This research started originally as a research working group by NATO, and we got some support for developing prototypes of those type of agents. But no, we're actually not contacting large companies, because fortunately we still have funding from public sources, and usually we want to let's say have everything as open as possible, and we're not sure how it will turn out with companies.
What is the end game for this? Are you expecting to have some AI, let's say, defender or attacker, or let's say some actor who will change setups in our networks in the end to keep it secure?
Well, that's something I would like. I would like to have those attackers and defenders say fighting against each other and bettering themselves. And one of the reasons is that what I see in the literature often is that the attackers are usually pretty stupid. They're not doing much of the complicated work.
It's not sophisticated.
Yeah, and that's then there's a perception that the attackers are like this, and the defenses are being tailored against those type of attackers. So I would like to have even better attackers, so that the defenders can get really better, and to have it, let's say, to move it to a higher level.
Okay, thanks.
Have you considered integration with CyberRange? They have on VUT.
Yeah, we also have one, and there's another step. Right now we have the simulation. We have a way to transfer it to emulation. Like we have some kind of configuration that describes how the infrastructure with all the agents looks in a simulated environment. We have a way to transform it to a Dockerized environment. And but all those configurations are pretty easily transferable, so we'll be moving it, those best agents or those agents that need to, for example, interact with humans, we'll be moving it also to that virtualized environment.
I guess these are all the questions we had. Before we all disperse, I've been asked to inform everybody that number one, there is going to be a social event today, so you can pick up your tickets at check-in during the lunch period. Second, there is going to be a way to get feedback on sketch.org. So if you want, you can say how you liked or didn't like the event. Third, after we have the social event around 21:30, I think, there's going to be some fireworks and drone show around the dam. So if you want to watch, you can join in. It's public, it's not funded or in any way endorsed by this organization, but it's a nice event anyway. And finally, there's going to be a win-win-win session tomorrow where you can win some swag for answering. Yeah, you can see that. That was just on the screen. So yeah, you can win some swag for answering questions. So yeah, that's kind of it. Okay.
to the second session of the second day of DevConf. I would like to welcome the speaker, Akanksha Dugal. Sorry, I forgot your, senior data scientist at Red Hat, who will talk about privacy in the open source. There will be a few minutes at the end of the session reserved for your questions. And without any further delay, I am giving the floor to the speaker.
Thank you. Good morning, everyone. Thank you for coming for my talk. So I believe everyone who's sitting in this room has a mobile phone, a laptop, and you all know, like, when you have access to internet, lots and lots of data is being collected from your machines, sometimes with your consent and sometimes without your consent. And it's really hard to track who's taking your information and what are they doing with it. But would it help to know that there's a way that all these websites will collect your data, will give you amazing recommendations and inferences out of your data, but at the same time will ensure that your data remains private and nobody gets to know your personal information. And that's why I'm here introducing homomorphic encryption that ensures privacy all around us. And the main focus here is going to be how we try to ensure privacy in the open source world using homomorphic encryption. So before we deep dive into this, I would like to take a moment and introduce myself. My name is Akanksha Dugal. I am a senior data scientist from the Emerging Technologies Data Science team at Red Hat at the office of the CTO. I originally come from Boston, United States of America, and I have my GitHub, LinkedIn, Twitter, all linked here. If you have questions or concerns about this topic, happy to chat about that. So let's move towards homomorphic encryption. I would assume that most of us know what encryption is, but still would like to take a moment to explain what that is. It's basically a way of scrambling the data so that only certain authorized parties would have access to the information of what that data actually means. And what is homomorphic encryption? It's basically the process where we can perform computation on this encrypted data. So as most companies continue to develop machine learning models, sometimes these machine learning models could be a key asset to the company and therefore cannot be directly shared with a client who wants to use this model on their data. And at the same time, this data is also confidential to the client, which they don't want to share with the company who's providing their machine learning and AI services to them. And that's where homomorphic encryption comes in picture. It lets you apply the machine learning from the company and client's data on that model without neither of them getting to know about the details of the private information that they have here. Talking about applications of homomorphic encryption, there are tons and tons of them, starting from healthcare to smart electric grids, from education to machine learning as a service. Name it, and homomorphic encryption can be applied to literally any industry where input privacy is the paramount concern. In my opinion, the most important use case of homomorphic encryption would lie in the healthcare industry, where precision medicine would involve a lot of privacy-related rules and regulations, and a lot of the companies who are in the pharmaceutical industry and creating medicines, or they need important data to predict what sort of medicines we want to have for certain kind of diseases. It's really, really important to also ensure the privacy and all the data that was concerned with the patient. So that's where homomorphic encryption is super important, because if you breach any of the rules and regulations associated to the privacy of the patients, it comes at a huge cost. So homomorphic encryption lets you just bypass that extra cost that you pay usually if you breach these rules and regulations, and it helps you still make good predictions using all the past data that we've collected over the years. And talking about how homomorphic encryption can be really vital in the open source world. As we all know, the benefits of homomorphic encryption is to ensure that there is a private, a secure, collaborative environment, and that's the common part with the open source world, where transparency is the most important thing we would like to ensure when it comes to open source communities and open source projects. And also at the same time, we would like to ensure that there is some sort of privacy and a secure environment for our contributors as well. Starting off with protecting sensitive information. So open source communities oftentimes deal with a lot of sensitive information. For example, there is user data, there is passwords, some financial transactions, and we would like to ensure that this data is not open for everybody, even though it's a part of the open source projects. And homomorphic encryption ensures that only authorized parties get to see the private information. However, we still try to ensure that this data is put in the right places, encrypted, and only used for the right purposes. Also helps in secure collaboration. So for example, there are sometimes multiple companies who are collaborating on an open source project, even though they want to put together their technical abilities, technical knowledge to this project. However, they do not want their proprietary information to be shared with this competitor company who they're working with on this project. So homomorphic encryption ensures that there is a secure collaboration between two different companies and developers while they contribute to the open source projects. Protecting the intellectual property. As we said that sometimes the models and the data that these companies bring together are an asset to these companies. How much ever they would like to contribute to the open source world, sometimes few things cannot be made public. For example, if you were to do an automated driving system, Tesla is like the only leader in the market at this point. But if other companies were to join hands and put together a machine learning model, put together data sets, but they cannot seem to share the data sets in the whole wide world. So what they can do is just put together their data, encrypt it, whereas all of them use it for the same model, ensuring that all this data that they've collected was private and still making good predictions for the automated driving systems. Finally, ensuring data privacy. It is also very important to ensure that any sort of personal data is protected from getting leaked. Also, a lot of open source projects have secure voting. So oftentimes we have to vote for some decisions that we would like to take in open source communities. If we want to go further with this project, do we want to get extra brownie points for this particular project? And sometimes people don't have the entire privacy to cast their vote freely. So homomorphic encryption is something that could be brought into picture and ensure that people have the right to vote and also just the privacy to vote for whichever project they want to vote for. So having said that, homomorphic encryption does have a lot of advantages. Starting from performing inferences on encrypted data, just like it would perform inferences on the plain data, there is no interaction that is involved between the data set holder or the model holder. And it also helps to just do the outsourcing for data storage. But everything comes with some sort of disadvantages. Since this is a computation that is performed on encrypted data, it is computationally very, very expensive. The normal computers are usually not designed for homomorphic encryption kind of workloads. So it comes at a huge cost, and even to do the smallest of the calculations, it takes a lot of resources to just perform addition or subtraction. Besides that, it also has some limitations in terms of the calculations that you can perform on the data. So the major thing when we do as a data scientist in any of our projects is data filtering, data cleaning, data comparison, but homomorphic encryption specifically lacks this use case where you cannot compare two values. It basically cannot let you know which value is lesser than the other value. And that also makes data filtering or data division an impossible task. So anything that involves operations besides division or comparison can be performed using homomorphic encryption. But this is the only limitation that we have so far. So talking about different types of homomorphic encryption, back in the 80s and 90s when we first started, not me, but when the world started to research on homomorphic encryption, the first scheme, the first type of homomorphic encryption was developed. It's called the partial homomorphic encryption. It was started with the Paylor crypto system. It allows only basic operations where you can perform addition and multiplication. This also has a couple limitations, which I'll go over in the demo as well. But you can perform 2 encrypted numbers addition, but you still cannot do multiplication between 2 encrypted numbers. You can only do 1 encrypted number and 1 plain number. So this does has kind of limitations, but if we talk about the era this was developed in, I think they were doing a pretty good job at that time. Then comes the somewhat etchy, which came up with some more advanced abilities. It supports only 2 operations, but it has more depth. You can like get into the technicalities. You can perform algebraic equations, and BFP scheme is one of the things that comes under the somewhat etchy. I would not go into too much detail about these schemes because I think that's a good topic for another talk. But just to give you an overview, somewhat etchy is majorly the BFE scheme comes as a part of the somewhat etchy category. And then comes the fully etchy. So as of now, most of the researchers and companies are using fully homomorphic encryption techniques to perform homomorphic encryption. It can allow you to perform any number of complex operations, any depth, exponentials, matrix multiplication, name it, and you can perform it using fully homomorphic encryption. At this point, even machine learning models like linear regression, logistic regression, CNN models, image detection, all of it is possible only and only because of the fully homomorphic encryption scheme. It uses the approximation of real numbers to make predictions and make calculations on encrypted data. So one small difference between how somewhat etchy and fully etchy are different from each other. So for example, we had 2 numbers, 2 and 3, which add up to 5. But somewhat etchy would approach this problem as encryption of 2 plus encryption of 3 is equals to 5. Whereas fully etchy makes you give an approximate estimate of what this number could be. It does not directly add 2 and 3. It would be somewhere around, say, 1.99 to 3.99, or it would say 1.99 plus 2.99, something which is like plus minus error of 10%. So it would not be an exact calculation, but if you see in long-term and complex calculations, this is actually much more accurate than just assuming them to be real integers. And that would cause some sort of errors if you're doing just like whole numbers at some point. So when it comes to complex mathematical operations, it makes much more sense to have the approximate feature where you can just go to decimal points and perform the calculations. So we also performed a comparison study on various open source tools that are available, and we performed some research on that. So talking about like the kind of work I do at Red Hat, our team is mainly focused on doing research-based projects in mainly Python, where we come up with machine learning and AI solutions for any sort of problems within and outside Red Hat. So as a part of that, most of our code is written in Python. So we thought if we have to integrate this feature in any of our projects, it would make much more sense to have this tool written in Python language. Whereas when you just first Google homomorphic encryption, you will see that Microsoft Seal, which is written completely in C++, it is not something that we can directly use for any of our projects. So the first challenge that we want to tackle here was we need libraries, open source libraries that are specifically written in Python and that can be seamlessly integrated with the code base that we already have. So starting with the Paylor crypto system, which is the first technique that was developed as a part of the Paylor crypto system. It's developed from 1999. It's a partial homomorphic encryption scheme. As I said, it does have limitations of performing operations. We can only do addition and multiplication of one plain text and an encrypted number. So this is kind of a shortcoming for this encryption system, that it cannot perform complex operations. But for anybody who's just starting to get into crypto system and encrypting numbers and getting into the encryption area, I think Palia's crypto system is the best way to understand the basics of this concept and to get an understanding of how and why we are doing all of this. Then comes the PySeal, which is also a wrapper function for the Microsoft Seal, but it has a lot of limitations in terms of trying to import this to our Python code. It has to be built with certain number of config files, and there are a lot of dependencies that oftentimes are hard to manage when it comes to open source projects where we would want seamless integration with new people, new projects. It's kind of difficult to manage something like this. So we thought that we'll research more about this, and then we found PyFHE. It was developed a couple years ago in MIT as a part of a PhD project. It's a fully homomorphic encryption library written in Python and includes the BFE and the CKKS scheme. It has almost all the operations that you would like to perform on your data, but like as soon as these people graduated out of school, they start maintaining this project. There's lack of documentation. How much ever we would like to use this, it definitely lacks a lot of documentation to be used on a long-term basis. And then we found out PyFHEL, which is also an open source homomorphic encryption library, has tons and tons of operations that are available. It has a very similar syntax to normal arithmetic. It's super easy to use, and it uses C and C++ in the backend. It's perfect for any sort of homomorphic encryption operations. But if you all know more about data science, most of our data is in the form of vectors, and when it comes to complex operations, we would also like to use vector arrays and things that you can use to perform on tensors. And finally, like, we ended almost our research on TenSeal. It is an open source library developed by OpenMinded. It is built on the top of Microsoft Seal. Super easy to use. It's literally a pip install TenSeal, and you can just start using it right away in your scripts, in your Jupyter notebooks. Super seamless to use, and with the ability to perform these operations on tensors, we can use PyTorch models, we can perform any sort of machine learning operations using TenSeal. So we've also done a proof of concept using TenSeal library. It's super easy to perform logistic regression and make predictions on any data that you have. So this is by far the most awesome library that we found. OpenMinded is also currently working on another open source Python library, which is very similar to PySeal. So basically, they're just reviving that old library, which was dead a couple years ago, and they're trying to revive it and also make it a pip install that you can use for any sort of data that you have. But TenSeal is more focused on tensors and vectors and complex machine learning algorithms. So I think I'm going to move to the demo and give you an overview of what we've done so far and how did we get to this research point. Like, it looks super easy, like we do like a comparison study, but like it's months and months of effort where we get to understand what we've done so far. And I would like you to also go to the repository and check it out. If this is something that interests you, you can just go to the repository where we have put together all the documentation and all the pain points that we went through. There's issues, there's documentation that you could go through. So starting off with all the notebooks that we've put together. So as I said, we started with the Python Palia. This is the most basic way of getting into the crypto system industry. You can just like go through the notebook and try to understand how and why we are doing this. So starting off with, we import this library from Palia and just assign two random numbers, and then we try to encrypt them and perform addition on that. So once we add them, we get the result, which is exactly the number that we were expecting. And we also try to do the same thing with a scalar and an encrypted number. Again, we got a correct result. But the most important thing to notice here is that how long does it take to perform this computation? I agree this is an accurate measurement of what this addition would be, but it takes a lot longer than expected. So if you look at it, the homomorphic addition took 92.8 microseconds, whereas the vector addition, which is the normal addition, it took 102 nanoseconds. So if you were to see the comparison of this, the vector addition is more than 1,000 times faster than homomorphic addition. So this comes at a huge cost of time and resources. But if you talk about doing a multiplication between two numbers using the Paleo library, what you see is they give you an error which says good luck with that, because they don't have the ability to multiply two numbers. So this was the first set of things that they started to work on in terms of homomorphic encryption, and slowly and gradually it improves, and that's what I'm going to show. So I'll go over to Tensile, which is like the final library, and make a comparative study of how this is better and faster from the Paleo crypto system. So Tensile, as I said, super easy to import. Just import Tensile and initialize a context with couple values and parameters that you would like to specify. Tensile also has great documentation on how you should parameterize your encryption keys, etc. Then we take couple vectors, try to perform addition. So we first perform ciphertext to plain text, which is one scalar and one encrypted value. And we also do the same for subtraction, multiplication, etc. But let's move to the ciphertext to ciphertext calculation and try to track the timing and memory that it takes to do so. So if you look at the addition, homomorphic addition took 24.9 microseconds, whereas vector addition took 1.71 microseconds. The funny thing to notice here is how far we've come. The last notebook we saw, it was a nanosecond and a microsecond, and now they both at least have the same metric at this point. So earlier it was more than 1,000 times faster. At this point it's just 15 times faster, which is still something that is doable with the amount of resources that are available right now in terms of performing any sort of computations. I think this is still a reasonable amount of resources that homomorphic encryption requires at this point. Then if you look at subtraction, that is also around 15 times faster, and then multiplication, however, takes much, much longer. So vector multiplication is 3,000 times faster than homomorphic multiplication. But if you all have done any sort of computations on data and machine learning, you would know that it's no piece of cake. It does not require just addition. It's much more complex than you would imagine. There's derivatives, etc. So it takes much, much more resources when it comes to the real problems. And that's why we performed a proof of concept to see how long and how expensive this is going to be to actually perform homomorphic encryption in the real world. So we did a logistic regression proof of concept. We took a data set from Kaggle. This is a heart disease data set, and we wanted to predict the overall risk using all the data that was available. So we have this data available here, like we just inspect what the data has. We just try to clean it up a little, remove the NA values, and then drop a couple columns that were looking irrelevant, and just quickly put together a logistic regression model without any encryption on this data. It's just like 5 lines of code. You mention a classifier and make a prediction and finally calculate the accuracy. And this is the final report that we get after doing basic logistic regression. And mind you, this takes literally a second. So this is Jupyter Notebooks for who don't know what this is. So Jupyter Notebooks is an interactive form of using Python code. You can just run each cell at your own expense. You can run these cells in any order, and you can get an output right away. So when the moment you click enter on these cells, it just takes like a couple seconds to show the result. So that's how fast creating models on small data sets or just non-encrypted data sets is. So now we move forward, we create a torch model, just try to initialize the logistic regression model here, which gave us a good accuracy on this data set. And then finally, we thought it would be interesting to do an evaluation on a model and the data that is encrypted and see how long does it actually take. So when we perform encrypted evaluation on this data set, let me just quickly go to the final part. So we try to do a couple epochs. When I was doing it on my system, initially I just tried 5 epochs because that's something that I just choose as a number to start my calculation with. And my Jupyter Hub, it just hung up on me because this was eating up so many resources. Then I brought it down to some less number of epochs. So I went with 3, and I thought that was a sweet spot where it wasn't breaking for me. The average time for each epoch to train here took 350 seconds, whereas the normal logistic regression would take barely a second to just run. And here it took 350 into 4. That's super long for doing any sort of basic calculation on a very small data set. So this data set has only 4,000 rows, and still it takes this long to make a prediction on this data set. But if we talk about the accuracy, it was much better than the normal one that we got on the basic logistic regression model. Might be a flake, but I would like to believe that it took its sweet time, used the encrypted data, but still came up to the level of the plain logistic regression model, which is awesome. So one thing we are sure of here, that if anything, this is an accurate model that makes accurate predictions, just comes with some shortcomings that it's sometimes expensive for you. But we are also working with a couple teams within and outside Red Hat to ensure that we can have some sort of accelerators and distribute our workloads so as to ensure that it is not as computationally expensive as it's getting. So hopefully, maybe next time we would have a much more optimized proof of concept where we are doing all of the same things but in a much faster and less expensive fashion. So that's about my demo. I will go back to the slides. I don't think we have the time, but I think, do we have time?
Yes, we still have 7 minutes.
Yeah, I can quickly go over the most frequently asked questions. So a lot of people ask, how is homomorphic encryption related to federated learning? These two go hand in hand, and a lot of people oftentimes confuse one for the other. Even though both of them ensure security, privacy, ensuring distributed workloads, collaborative environment, they are specifically different from each other. So homomorphic encryption is basically, I have the model and you send your encrypted data to me. Whereas federated learning is just training machine learning models on decentralized devices. Basically means that there is a model somewhere, and I encrypt the model and send it to the people who have their data that they cannot share. So for example, if there's a pharmaceutical company who has sensitive patients' data, and they would want to use my model, and they'll tell me that, oh, I have huge data sets, I can't possibly encrypt that and send it to you. So what I do as a data scientist is that I encrypt my model and send it to them, and they can just use it at their own expense and try to make predictions on their data. But coming back to the initial statement that I made when I started my talk was that lots and lots of websites are collecting data, and I don't want them to see my data. I don't want them to just openly use my data to make predictions. Homomorphic encryptions ensures the privacy of the data while making predictions, but federated learning is something that that company would still have access to your data. The model, which is a proprietary information to a different company, that is the encrypted part here. So I still think when it comes to the privacy of ensuring contributors' data or customers' data, homomorphic encryption is the way to go. But federated learning is no bad. I think it still ensures that your data lies within the company and doesn't go out in the open world. So that's the comparative study between homomorphic encryption and federated learning. And Another more frequently asked question is how is it related to confidential computing? So confidential computing involves a lot of hardware, and you need to ensure that you put your data in a private spot. So for example, Amazon, Microsoft, all of these big players are putting up storage centers where they ensure the privacy of your data by putting them in a remote location. Which is also, again, very expensive. Not only does it require storage space, it actually requires a physical space to store all of this data somewhere in a private environment. So that's like the main differences between homomorphic encryption and confidential computing. There are a couple blogs out there that you can check out to understand the differences between the two. This is just like my study on how these two are different from one and the other. So that's it from my side. This is the GitHub repository and my email with my colleague who's worked on this project. Please feel free to ask any questions or concerns. Feel free to raise issues on the repository if you're interested to contribute, and I would be happy to help you out with that. There's a question.
Yeah, feel free to ask any questions now.
I have a question. All the tools you demonstrate are Python based, right?
Yeah, so all the tools that I mentioned in the presentation were based in Python.
Well, in real life, when we want to care about big amount of data and don't want to reveal them, it means that we should store the data in some database. So if we can process this data only with Python tools, it means that the encryption should be done somewhere between database and Python tools, which looks suboptimal. It would be better to store this encrypted data in database and provide a result and calculation in the database itself. So I'm not sure that script languages are the best tool if we dealing with real data security. Thanks.
Thank you for your question. Yeah. I'm going to repeat the question. So he asked that since we put all our data in the database, it's oftentimes, like it involves a lot of operations to encrypt the data. Shouldn't we do it before putting it somewhere so nobody has access to the exact information? Is that right?
Sort of.
Yeah, okay. Yeah, all right. That's a very good question. So as a part of this project, we have just done a proof of concept, and the whole point why we use Jupyter Notebooks is to just see the results the moment we perform any sort of calculation. But if we were to talk about the real world where real data exists, we would try to create a pipeline of this data. So the moment the data is being collected from our customers, it should be in the pipeline where a script runs on this data and ensures that before it reaches the database, it should be encrypted. And once it's in your database, it's already going to be encrypted before that step. And from this database, you can choose any sort of calculation or algorithm that you want to perform on this data, ensuring that the data was still private. So I think this is all customizable. I just threw everything together in one notebook. It's super easy to put them in different scripts and in different order of the pipeline that you would like to perform this operation on. Yes.
So you showed the toolkit, the Python toolkits.
Mm-hmm.
And for fully homomorphic, they were supporting CDDS.
Yeah, CKKS.
Do any of them support BGP?
Yeah, so fully homomorphic encryption has CKKS and BGP schemes both.
Okay, and those libraries, you had on your slide, it just said CKKS.
Yeah, when I say like, yeah. So most of the libraries that support CKKS also support the BGP scheme.
Okay.
Yeah.
We have time for one more question.
Go for it.
Okay, I have to ask. So this was like simple linear regression, right?
Yeah.
So am I to assume that the same performance hit would be when you would try anything else? I mean, that's a reasonable assumption, right?
Mm-hmm.
then essentially, if I were to try to confidentially write something like, actually industry grade, let's say standard image recognition, let's say exception in net, okay? Retrain it on something fairly simple. That would, on any reasonable hardware, if I'm right, take several years, probably. Because since this is 2 orders of magnitude hit, I mean, if ever this became industry standard, then it would essentially push everybody out of the machine learning market except for 2 companies. Because nobody else could afford it, right? Because doing this confidentially essentially means either not doing it all or having a status level budget, right?
That's a great question, and this is the fear that a lot of companies, like even us, thought would be a really big con for us in terms of homomorphic encryption. It's super hard to do extensive calculations, but trust me, there's a lot of research going out in the entire world where people are working towards this. Personally, my team is currently working with the Boston University, where we are trying to come up with some sort of FPGA that helps us accelerate, distribute our workloads, along with some not so very expensive hardware that would still allow us to do the same sort of operations, but at a lower cost and a much faster process. Besides that, there's also different ways where we could write our code in a way, probably just distribute our code in a way that it's easier to perform calculations so that it doesn't eat up a lot of resources, because the biggest resource it's eating up right now is the memory, where it creates the keys, then encrypts the data, stores it somewhere. That just eats up a lot of memory. But if we have a very distributed way of performing all of this meticulously, I think with time, the day is not far where we would be able to do all of this seamlessly. And about the image detection, there's a lot of research going on, MNIST data set, if you're aware of that, where there are numbers 0 to 9, and there are pictures of these numbers where the machine learning model tries to recognize the number just by looking at the picture of it. So there's CNN model, which a lot of people have been exploring on Kaggle using homomorphic encryption as well. There's a lot of open research going on that. And it's somewhat accurate at this point, just that since this is an image, it takes longer. Even in normal machine learning, the image detection is much harder than numbers.
Yeah, but that and this data set, that's very old. That's the standard, the first thing you do when you try to do any machine learning, and it's 5 seconds to do something with it that you don't encrypt it. So this takes 5 minutes. Then I mean, that's incredible disadvantage for anybody, of course.
Exactly. But we do have to give the benefit of doubt to homomorphic encryption, because in 1999 was the first time where there was an actual homomorphic encryption system that was developed, and we've come so far, and since we are starting with logistic regression and CNN models, I think it's only the beginning of this era for homomorphic encryption. And in no time, probably in a couple years, this is the ChatGPT era. We never know when we just reach that point where we are able to do all of this seamlessly soon.
Okay, we are at the end of our session, so big thanks to Akansha.
Thank you.
And don't forget to be at the reception at 12 p.m. as the
Okay. Thank you. All right. Hey, everyone. Thanks for joining us. My name is Oindrila Chatterjee, and I'm a senior data scientist at Red Hat. And I work in the emerging technologies group at Red Hat, and I am coming from Boston, United States. And today we're going to be talking about uncovering new open source communities using graphical analysis and network analysis. And I'll let my colleague introduce herself.
Thanks, Andrilla. So, hello everyone, my name is Hema Viradi, and I'm also working as a data scientist in the emerging technology group at Red Hat. And I'm based out of California in the United States, and if you want to connect with me later, you can reach me on LinkedIn, GitHub. Feel free to reach out to us after the talk as well. So, before we get started, I would encourage you all to answer this question that we have by scanning the QR code. So this is just a live poll to get an understanding to know what is your role right now in open source. So are you a developer? Are you a project owner? Are you a project maintainer? Whatever it may be, feel free to put in your answers over there, and we should also start seeing it populate as well. So I see there's a software engineer, data scientist, so more software engineers. Gonna give a couple of more seconds. But yeah, so as we can see, we all have different roles to play in this open source community. Our majority, I'm guessing, here at this conference are more from a technical perspective. So we are more of developers and engineers and things like that, right? So all of us have this important sort of role that we play. And part of the motivation of this project, or the kind of goal that we want to do in this project, is firstly, we want to identify and get notified about the early and emerging open source projects that are existing out there. So we all know that the community is so large and so big that it's sometimes unclear for us to sort of pinpoint and identify those new and emerging projects. So that's one thing that we would like to achieve. Secondly, we would also like to look at the communities around these projects. So we want to track who are the important user groups, who are the important core contributors, who are your open source ecosystem main sort of maintainers, and how do these kind of evolve over time. And finally, we would also like to graphically visualize all of this. So that's where the network analysis and social graphical analysis that we're going to talk about comes into picture. So what we want to do here is we want to sort of identify the maturity of a project over time, and we want to see where the interrelationships between projects exist. So how does network analysis help in achieving these goals, right? So we talked about looking at early notifications, trying to track those important projects. So one way to do this is representing them graphically. So what we do here in the first graph that you see is you're trying to depict your projects or your GitHub, basically your GitHub repositories as your central nodes. And you're also trying to identify the contributors around these different projects. So you're trying to see, how many contributors exist in a particular project and so on. And we want to further dive down into that graph a little bit more and look at what are the important nodes that exist in that graph. So that's where all those graphical algorithms come into picture. So you're trying to identify which are the top most important nodes in that graph, and try to identify the influential users and so on. And then finally, we also want to look at it from a time perspective. So you want to see the growth of a project. Let's say you're starting a new project. You want to sort of project what the trajectory might look like over time. So you also want to track all of this in a historical way. And ultimately, we also want to incorporate some AI and machine learning capability to sort of predict what the trajectory would look like for this project to succeed. So that's kind of how network analysis can sort of tie all of this together. And all of this kind of effort is part of a larger initiative called the Project Aspen. So Project Aspen is an open source project which is mainly developed at the open source program office at Red Hat. So what Aspen does is it has a couple of components that are currently actively being developed, which we are also using in our project, in our work. So firstly, there is a tool called Augur, where we collect all of our open source project data from. So Augur essentially is scraping all of the data which is from GitHub, and we mainly use that tool to collect all the information from various GitHub repositories. And we also have a visualization tool called 8-Knot. So this is an interactive dashboard. So what you see on the graph over there on the right is developed by these dashboards. So that's a tool that we also have where you can sort of filter which repository you're interested in, and you can sort of see some metrics like community health metrics, project activity over time, and things like that. So there are some inbuilt metrics in the dashboard that you can further look at. And then we also have the REPEL repo, which is the main repo where we do all of our research and open-ended sort of experiments to look at, which is what we are contributing to. So that's a little bit about the larger initiative. And now we can come to the representation of these projects that we talked about in a more graphical format. So if you look at the first one on the left over here, we see that the central nodes are basically your project. So it represents a particular repository, and you can also find out who are your contributors which are surrounding that particular repo. So here we do not, pinpoint contributors. We're completely sort of obfuscating that part of it. So we're making it very private, and it's more like just looking at the contributor IDs, and that's how it looks like. So some of these projects have a larger sort of dense contributors. Some of the smaller ones, like the purple one, have a lesser kind of population around it. So this is one way to represent a particular project. Now, if you look at the second representation, again here, each of the nodes represent your repositories. But what we're doing in the edges is looking at the number of shared common contributions that exist between those repositories. So that's how it's slightly different from the first representation. So the edge between those two nodes is basically like the weight of the contributions that might have exist between those projects. So those are defined by the activities that happen in the project, which we will come to a little later in the slides. But this is kind of how we would represent it from a graphical standpoint. So, oh yes, you have a question.
A little question. So, are you representing the number of shared contributions as the length of the edge?
As the weight of the edge.
And
so,
also the length.
And yeah, and also the length. Mm-hmm. So if you see a larger distance, it's probably because they have a lesser number of contributions, whereas if you see them being a little more closer, that means the weight of the contributions is a little higher. So yeah, that's how the representation is. So next we can move on to representing projects as nodes and the shared contributions that we were looking at as edges. So here the main goal to do this kind of representation is you want to sort of aggregate all of those shared activities in those nodes, and then you want to sort of also further drill down and filter out those which might not have a lot of activity, so that you only focus on those key sort of projects in those nodes, right? So for example, here we're trying to look at some of the more popular Kubernetes-based repositories. So we have a couple of Kubernetes repos. We also have some of the OpenShift repositories. So OpenShift is again very much related to Kubernetes. So these are some projects where we picked because of their sort of known connections to each other, and we try to look at how close they are, how far apart they are, so that the goal is that when you visualize it like this, you can actually identify those which are emerging, right? So if you know one very well-known project, let's say Kubernetes, you want to know what are the other projects surrounding that very well-known project, because those can potentially be your next emerging project. So you kind of want to identify those key links between each other. So that's what we're trying to do in this particular representation. So what exactly counts as those shared activities, right? So we saw those edge weights between those different nodes. So what we count as an activity are things like issues, PRs, commits, PR reviews, and things like that. And the weight that we defined is defined by, what is the strength of the connection based on those type of contributions being made. So basically you're looking at, are these contributions done by a maintainer? Are these contributions done by a developer or a core contributor, and so on? So that's how those edge weights are being defined. And then finally, you also want to find those emerging projects. So we look at some metrics for a particular project, like how many number of forks does this project have? How many number of stars? How many number of stars does this project have? And then, of course, the activity trend over time for a particular project. So that's kind of how we look at all these different shared activities. So again, if you can take the poll and answer this question, you don't have to scan it again. It should already be there in the previous tab that you had open. But I want to ask you all, what do you think makes a project rapidly emerging? So you have a couple of options to choose from. For example, do you look at the growth in the number of stars that it has? Do you look at the number of issues? Do you look at the external popularity of that project? So kind of rating what you think is most important over here. So I see some votes coming in. Some people are looking at the issues, PRs, commits as the most important. Some people are looking less in terms of the number of forks, number of stars. So I guess most of us are more interested in the activity of a project. I'm going to give a few more seconds for folks to add their responses. Okay, so we have some people who are interested in external popularity, so that's nice. You want to sort of also see, apart from PRs and commits and all of that, you also want to look at it from external factors, right? So maybe you've heard about this project in some other outlets, so that's also an important feature. Awesome. So yeah, thanks for participating. These are all good responses, and you can sort of see that each of you, based on your role, also as kind of weighing things differently, right? So that's what we can also take into account when we do this kind of analysis, to make sure that we're capturing the right set of activities that you think is important. And that's how you can sort of gauge where your project lives. So following up, one more question that we have for you is, what is the most important insight that you're looking for from your own community? So most of us participate in some kind of open source community. So what is it that you want to learn about these communities, right? So whether you're a first-time contributor or whether you're a veteran contributor, what do you kind of look at and what is important to you when you are thinking about these communities? So you can feel free to add your responses over here as well. Okay, so what do we need to change to attract more users and contributors? Yeah, that's a great point. So you also want to see how can we improve communities, right? So what are some things that you should focus on to improve? So that's definitely a good thing to look at. What part need help to connect them better? Okay, yeah, so examples of use cases. What's one next project that could be interesting? Exactly. So that's something that we want to also gain from these kind of analysis, right? So you know that this project is existing, but you also want to know how do we make this project bigger? So I see somebody said, how do you make it bigger? What can be some other things that we can contribute to make it interesting? So yeah, these are all great insights, and we hope to incorporate these kind of insights into our analysis further. But yeah, thanks for all these suggestions. And these are some things that we are also looking at. We're trying to understand what community managers are interested in, what contributors are interested in, what developers are interested in. So depending upon your role, you kind of look at communities differently. So that's the reason why we try to get data from different set of projects and try to sort of aggregate them in this graphical representation. With that, I would like to hand it over to Oindrilla. She's going to talk more about these algorithms that we've implemented.
Awesome. Thanks, Hema. So now that we looked at more of the questions or some of the goals that we want to achieve from these projects, let's try to look into some of the more technical details and how do we get to assessing these goals. So firstly, to do that, we researched some algorithms which are graph centrality algorithms, and this is sort of one of the most important area of research when you're trying to identify key players or important players within a graph network. What do important nodes within a graph network mean? So in terms of in graph language, important nodes can mean, number one, they have a lot of links or a lot of direct connections to them, or it can mean that that particular node can reach other nodes in fewer hops. It can reach other projects really easily. And another meaning could be that it really sits in between projects. So it sort of lies in between the shortest path of different projects. So we'll go over a little bit more into what this means for GitHub repos, but before we get there, let's get into some of the algorithms that we researched. So the first algorithm that we looked into is PageRank. And PageRank is one of the most popular algorithms, which was, again, Google came up with this. And this was used to rank web pages or websites, which are the most popular within Google search rankings. So in terms of using PageRank for our use case, PageRank has a variety of use cases, starting from social networks to molecular biology. So for our use case, we actually use these nodes, since these different nodes represent different GitHub repositories. These edges between them are common contributors or common contributions. So PageRank can be actually used to detect the most prominent nodes within this graph network. So, however, it was great when we tried to apply it to some use case. It was great at identifying the important players, the most veteran or the most well-established projects, but it was not good at identifying projects which are important in relationship to the other projects in the community. So for example, if we knew a list of well-established projects, and if we are trying to understand that in this ecosystem, for example, containers, what is another projects which could fit into this group, PageRank wasn't really good at filtering out or finding projects in relationship to other projects. So another algorithm that we looked at is betweenness centrality. So this was also our main aim, was to find influential nodes within this network. What this algorithm essentially does or means is that it tries to find nodes which almost sit in between other nodes. So it almost lies in the path of the different projects within a network. So we tried to test this out on Cloud Native Computing Foundation projects. So we applied this on a bunch of CNCF projects. And I'll also go a little bit more into this later. But what we saw was that the more veteran or the more well-established projects almost had higher betweenness centrality scores. And the other projects which were new or which were just introduced in CNCF had smaller betweenness. And something which was pretty interesting, which we saw with betweenness centrality, was that this was good at also emphasizing on a node's popularity in the context of the repositories which it is a part of, the ecosystem that it is a part of. The next algorithm that we looked at was closeness centrality. And again, this is also a way of detecting nodes which are closest to each other. So this can be used to find nodes which are at a shortest distance from an existing node. So we essentially use this to find nodes which are most well-connected or the closest to a well-established project, so that we get a better understanding of projects which are almost interdependent on each other. So, so these were the key centrality algorithms that we looked at. So now we wanted to, now that we have an understanding of these algorithms, we wanted to apply this to certain use cases and try these out on some real world cases that we can try this on. So one of the first use case was identifying OpenShift, which for those of you who are not familiar, it's the enterprise version of Kubernetes. So we wanted to identify OpenShift almost as a downstream of Kubernetes. So in the years 2011 to 2014, Kubernetes was a well-established project, and OpenShift was emerging as like a downstream of Kubernetes, and we wanted to trace back in time and see if we can detect those patterns just using centrality algorithms. So we tested this out on 3 control groups. One was well-known projects. So we added Kubernetes and Docker, which are very much related and which were very established during that time frame. And in the emerging projects, we wanted to detect OpenShift. So that's what we added in that field. And in the last section, in other communities, we included certain projects which were also emerging and which were appearing in different like news outlets and which were coming up in those years. Like Apache Hadoop, Apache Mesos, the Jetty project, and so on. And we wanted to see what these algorithms show us. So the first thing that we did was we wanted to see, like, during those years, what the trend looks like for these projects. So we particularly picked one OpenShift project. And as you can see here, I can also just quickly show you the real dashboard. So we saw that like during those 2011 to 2014 ranges, the pull request activity and also the commit activity and the contributor growth for this OpenShift repository was actually growing. And we saw that this is actually like a prominent project during those years. So we actually went back and represented these sort of data points from that Git repository in graph representations, and we applied these algorithms to it. So the first thing that we saw upon applying betweenness centrality was that this was very effective at highlighting Kubernetes and the Docker repos, which are obviously well known. So the red nodes and the blue nodes that you see are sort of the Kubernetes and the Docker repos. But we also saw that the OpenShift repos were showing in the graph, like the green repos are OpenShift. It actually came up. But the other community repos, like the purple ones, were insignificant. Although they were very key players, they were not really important in that ecosystem, and that's why that was almost effectively filtered out. And the second representation, we saw that this was even better at filtering out those other community repos. So here we see that sort of Docker and Kubernetes are pretty closely related, and then the OpenShift repos are also there in this ecosystem, although a little further away. And the second use case that we tried this on, I'll just go over very quickly, was actually representing CNCF projects using graph algorithms. And so Cloud Native Computing Foundation actually ranks projects according to different maturity levels. So graduated projects are the most veteran projects, and the sandbox projects are the more newer projects. So we wanted to see if we can use these graph techniques to essentially represent the maturity of a project in a way. So we tried like a subset of CNCF repos. We tried around 75 repos, and we saw that when applying the second graph representation that we saw before, where the edge lengths are almost like the closeness or the degree of connection between those projects, we saw that the graduated projects were sort of central in the repository, and the sandbox projects were a little further away. Incubating projects were somewhere in the between, which is almost very similar to the maturity delineation that CNCF does. What was more interesting was the betweenness centrality scores. Here we saw that the graduated repos were the biggest blobs, definitely more prominent than the sandbox and the incubating repos. And without going too much into detail, I will show the overall rankings that we collected from this. So what we essentially did was all these different centrality algorithms, we scored each and every project based on the ranks the nodes were getting, and we normalized them and added all those scores to get like a final scoring for each project within that control set. And here we were looking at about 75 CNCF repos, and we sort of just picked a few top end projects within like each category that we already know. And we saw that also the scores were sort of analogous to the maturity level of the project. So the graduated projects had like a higher total score, incubating projects had like a medium score, and sandbox projects had a lower score. And this was pretty interesting to see, because this also means that such scoring or these graph algorithms can also be used to identify which projects can be next introduced in the foundation, or can be used to better quantify these decisions that we are making, or also can be used in context of an organization. So yeah, that's all we had to share with you today. In terms of some ongoing efforts, we are also trying to extrapolate this work onto contributors or users. So applying these sort of algorithms on the maintainers, core contributors on a project, and actually seeing the sort of key players for each project. And we're also trying to periodically come up with lists of new projects that we want to introduce into the database so that we can analyze them further, because our research is just limited to the projects that are in the database. And finally, we also want to prototype these like cool graphs and these plots that we saw into the Aspen dashboard that we saw earlier. So that would make it very easy to like filter down and use these graph algorithms outside of a Jupyter notebook or outside of like a Python environment, just making it easier for non-technical participants of a community to drill down. So yeah, here is the project repo where we are prototyping a lot of this work, and in that folder you'll find a lot of our notebooks. Again, there's a lot of like documentation of this work, and this is a collaboration that we've been doing with the open source program office at Red Hat. So if you have more questions, have ideas, feel free to reach out to us, or open issues, or just look through our work. And yeah, that's all we had for you. If you have questions, you can ask us now, or also enter it in Slido if you're shy and just want to type it out. It's up to you. But thank you so much.
Thank you. And we have 4 minutes for your questions, so if you have any, feel free to ask them now.
Yes.
Have you considered also scraping GitLab for data?
That's a good question. So right now we are relying on like the Augur database, for which Augur's it's a Chaos Foundation project, and I think their main data source is GitHub right now. But I think like the APIs are like very similar. So if Augur is able to like ingest GitLab, I think the analysis is essentially the same. So it really or if there's a separate database that we can fetch data from, I think it's easy to just get GitLab data as well.
So you're using Augur as a source of your data?
Yes.
The data from GitHub?
Yes, we are not directly getting it from GitHub, because you know how API calls and API limits and everything is. So Augur has been a very sustainable, great source for us, because it also has different tables, and it really has a very extensive schema for like different kinds of, like it really helps us go from like a project to another project, and has great links in terms of contributors, participants, and it's a good relational database schema that just helps us.
So you're using the relational database as the source, not
Yes.
the database?
Yes, it's a relational database which we feed into for more unstructured analysis. Like definitely our analysis is more like non-relational, more unstructured, but our source is all like SQL queries, and then we ingest it into a Python environment. Yes.
So what do I need to do to get an analysis of my own projects?
Reach out to us. Like if you want to open issues, or we can talk further. Honestly, there are more use cases like we saw earlier that we are willing to try this on. So if yours is a community that you have ideas about, you want to gain some insights on, we can work together and just spin something up. Yes.
Were you able to identify emerging project by category, like for example, emerging security or machine learning projects with one of the tools you presented?
Yeah, that's a good question. So that's something that we are currently looking into. So as of now, we sort of looked at like a specific defined use case that we can test and validate. But the next step is exactly to your point. We want to do this internally at Red Hat. So we want to also identify like what are the top security projects, what are the top cloud native projects. So that is something that we are going to do next, to look at it from that particular vertical in a given organization. So yeah, good question. That's something that we're looking at.
Yes.
One more question for me. So, what practical actions does your data inform at Red Hat? What does Red Hat do with that data?
That's a great question, and I don't know how much of this I can go into, but in general, I think we are a part of the emerging tech group, and we work closely with the open source program office. And usually, the goal for us is to look at, what are some emerging projects which can be useful to Red Hat, or which can be a good community for us to just invest in. So the ideal goal for this is to inform those decisions, and also for us to validate some of our investments in terms of, quantify it better and just see that if there is enough data backing, if there is like metric backing, or if there are like some indicators that we need to be aware of before we take the next step or the next action. Yeah.
Sort of looking like for return of investment, like if it's the project is taking off.
Right. Mm-hmm.
And also if it's any new like incubating project that's happening at the company, just to sort of keep an eye on like, are we having the right resources for it? Is the project going how we expect it to go? What are the big, like next milestones that we should be planning for and things like that? So kind of looking at it from that perspective.
Thanks.
Okay, we are at the end of our time, so thank you again.
Thank you.
Thank you.
And it's lunchtime, so if you want, you can go grab something at food trucks.
There's a break.
Yeah, sort of. And also remember that at 12, we're going to be handing out tickets to the social event. So if you don't get a ticket, so
You can't get it again.
yeah, you can't get in.
Just give us a call. It's not a difficult.
I did not look at the time. But I'm really glad you made it. I think our content is so huge. We still have a few minutes for questions, so we are all
Každopádně já bych si vzal spoustu věcí.
Okay, everything's set. So welcome everybody to my talk. I'm excited that you came to it. Not scared of the parentheses. Well, that's a joke aside. The talk will be about half an hour long, and I'll show in the beginning there will be a bit of theory, some explanations, and later on about from starting in the half there will be practical examples. Okay. If you have any questions, if they are short, you can ask them in between. If they are longer, perhaps wait for the Q&A. I plan to have 5 to 10 minutes Q&A, so we should be on the longer side. My name is Adam, and I will be presenting here about superpowers for Clojure and ClojureScript. Who am I? I am a co-founder of OrgPad. As you can see, you can write me an email, and I'm responsible for infrastructure and security there. So perhaps some of the stuff that you will see, you will think, oh my God, he is connecting to some production environment or whatever, but that's fine. I know what I am doing. So about Lisp. Why am I talking about Lisp at all? Well, Clojure and ClojureScript are dialects of Lisp. And there are many people talking about Lisp, and Hacker News main page there is every second day something about Lisp or Clojure. Just today I have looked, there was a discussion why was Reddit 1.0 written in Lisp and then they switched to Python, and what is it all about? So I have put down some quotes about Lisp. You can see the XKCD in the middle. These are your father's parentheses, elegant weapons for a more civilized age. Stuff like that. Many people are saying very positive things about Lisp. And of course, there are some people that tell very negative things about Lisp. And so what is the buzz all about, right? You can see the quote by Eric S. Raymond. Lisp is worth learning for a different reason, the profound enlightenment experience you will have when you finally get it. The experience will make you a better programmer for the rest of your days, even if you never actually use Lisp itself a lot, right? So about that enlightenment experience, I hope I will convey some of it to you. So what is Clojure about? Why should we have another language? Why should we, develop stuff at all? Why should we think about these problems? Why should we consider different approaches to programming? Well, we have many problems running and evolving informational systems. Among other things is that we tend to solve puzzles. We have difficult constructs that we occupy our mind with, and then we don't solve the problems. We solve puzzles, but we don't actually solve real problems that customers are willing to pay for. As the systems grow bigger, we tend to encounter a Tower of Babel, that we have so many different approaches, so many different modules, and everything is kind of interconnected and not in the right way. It's getting difficult. It's tangled spaghetti, right? Also, when we write some languages, we tend to discover some hidden semantics. We discover that perhaps concatenating two arrays is not an array, or concatenating an array and an object produces different things depending on the order of operations and so on. So these are all small puzzles again, right? Hidden semantics, hidden syntax that we don't intuitively know what to do with, right? And the problem is that we don't have any predictability. So we cannot go to the boss, we cannot go to the customer and say, okay, we will finish our job in like half a week, and then we will do some integration tests and so on, and it will be all hunky-dory. We don't know. That is, we are not sure. We cannot promise, and that is really bad, and that's keeping the whole industry back. So, are we perhaps not using the right approaches? Do we have the right foundations? Well, that's a good question. Well, there are some approaches well known, usually more in the functional programming space, that we try to focus more on the what, not the how, right? We don't tell the computer exactly each step, like we are not micromanaging the computer, we are more telling, okay, this is like the overall idea I want to have, right? And that is obviously taken to the extreme with the AI bubble right now, right? We don't even know what the computer is doing precisely. Right? Perhaps we are too much focused on rigid and mutable data structures that are perhaps good for performance because the processor can work more efficiently using this, but we as humans are not very good at understanding these small places connected to somehow to another. We are not good at shuffling bytes and bits as humans, and obviously we all the time we have problems with state management, right? Concurrent programming is very difficult, and somehow we don't have any good tools to cope, right? So what can we do? I would like to focus on what is actually data and what is code. So, well, data is information. It's information in itself. It has to be processed to convey some meaning, right? And it's especially data doesn't or is not instructions how to do something. It's not. We can record some instructions, but for them to be instructions, we have to do something extra, right? For instance, run this as code. Right? So, what is code? Yeah, well, that is the set of instructions I was talking about. So that is the 0.5 in the Merriam-Webster dictionary, instructions for a computer or within a piece of software. So. Yes, that's about the definitions. You are probably not much smarter right now. So I try to approximate or show some examples what I mean. Well, we have many complex systems, and they run, and we don't usually change much in those systems. We configure those systems. So to some degree, it is foreseen by the designers of the system that this will be possible somehow. If you configure the system correctly, you will achieve some goal. And so you have some Red Hat technologies, for instance, like Ansible, and of course you have some configuration files like this, right? So. So that is quite understandable. But what about web browsers? Do they have any configuration? Right? What do you think? Well, HTML is kind of a configuration for a browser. The browser has to render this based on the input, but it's a configuration, so to say. Yeah, we have Maven. If you are in the Java world, then you probably know. It's a build tool, and also it has a configuration, of course. So is this data or is that code? Well, it's an instruction how to put pieces of software together, right? But it's represented as data. It's not Java code, it's XML. So there is some duality to data and to code. So what can we do about it? Well, we could, for instance, think about it in the context of compilers, another big system that we configure by putting in a stream of characters out of which a program gets compiled, usually, right? And that is all very, very complex. Well, we can perhaps think about some other ideas to represent code and data with the same means. This is a joke about Lisp and parenthesis heavy syntax. So I want to introduce you to Clojure finally. What is Clojure? So Rich Hickey, the author of Clojure, wrote on the website, Clojure is a dynamic general-purpose programming language, combining the approachability and interactive development of a scripting language with an efficient and robust infrastructure for multi-threaded programming. Clojure is a complicated language, yet remains completely dynamic. Every feature supported by Clojure is supported at runtime. Clojure provides easy access to the Java frameworks with optional type hints and type inference to ensure that calls to Java can avoid reflection. Clojure is a dialect of Lisp and shares with Lisp the code as data philosophy and a powerful macro system. Clojure is predominantly a functional programming language and features a rich set of immutable, persistent data structures. When mutable state is needed, Clojure offers a software transactional memory system and reactive agent system that ensures clean, correct, and multi-threaded designs. So what's this all about? That's very condensed, right? So dynamic, what does it mean? Well, there are no explicit static types. You don't work for the compiler works for you, right? General purpose programming language. It's suited for application programming, for all kinds of real-time systems, web development, right? Perhaps it's not as suited for driver development, but if you can imagine writing drivers in Java, you surely could write them in Clojure as well. So that's about it. The interactive development of a scripting language. Well, it's dynamic, so it's much less code. It's not as verbose, and therefore it's much easier to type interactively and do something. Efficient and robust. Each time you write something in the REPL or evaluate a program, then it gets compiled down to GTID JVM code. So the efficiency should be similar to Java, right? Depending on how you write. And everything is supported at runtime. So everything, if it wasn't, it would be very hard for the interactive development, because you wouldn't know what you can evaluate at runtime and not. It would be very difficult. It would be not non-predictable, right? And what it means to be a dialect of Lisp, I will try to answer in the next slides. So the language has some common literals. I think you recognize most of them. However, I want to point out the last 4 lines, the nil, ratio, symbol, and keyword. Well, nil is similar to null. However, in the Clojure script dialect, you know, there in JavaScript you have null and unknown, right? And so Clojure script doesn't have it, and both is nil. Ratio is very useful if you want to represent fractions exactly. so that you can basically defer losing precision to a later point. A symbol is useful. You can think of it to some degree as a variable. It's something that can hold a function, that can hold data. It's a name for something, basically. And the keyword is something like a label. So it represents itself, has some function, has some properties of a function in certain places. And especially a useful thing is that it can be namespaced as pretty much anything in Clojure. So you can, if you represent users, then you have some data structure. For instance, if you retrieve a list of users from a database, then you can say, okay, I get all those users as a sequence of maps, and each of the maps has keys that are named username, user last name, user date of birth, and so on, right? So I have spoken about sequences and collections. So there are 4, the typical list, vector, map, and set. They each have some interesting properties, very useful for programming, and I will show them in a moment. So, yes. So how does a function call look like? Well, you see it's basically a list that has 2 elements. The first element gets evaluated. It's the print function, print line function, and the second element and any other element would be arguments to this function. But you could view it as a list, right? So how do you define a function? Well, again, it's a list, has 5 elements. First is the definition, then the symbol that holds the function, then a string that is basically a comment or not documentation string, basically, and then a vector of arguments. Here you can see that is 1 argument, and then there is a function that gets called. It's a string function, so it basically concatenates hello and then your name. Right. And you could view it that is the same as I said. So, what is great about Clojure? Consistent and predictable syntax and semantics, because everything is a data structure. So that is very simple. It's easy for the compiler to evaluate it. The whole parsing is basically 800 lines of Java code, and that's it. So that is the first stage of your compiler, more or less. You have persistent data structures. What's that all about? I will show in the example. So, because we are a bit short on time, I will change to the example. Just let me set up. I'll connect to our testing infrastructure, and I have SSH'd in. Basically, we have a running application in the staging environment, the application server, and I'm now connected directly into that server, into that application. So that is quite common. You can imagine that is like if you had a Python program and you had the command line basically would be directly connected to the running program. So, is that big enough for you? Can you read it, or should I make it bigger? I will make it a bit bigger. Better? Yes. Okay. So what I will do. So this is the REPL. I could like write something here and it will evaluate, and that runs on the server actually. So but that is not how you develop software, right? You have an IDE and you have everything in an editor, and that is what I will do in the last few minutes. So imagine you have some problems in production. You have people connect to your server, and then for some reason these connections drop in some circumstances, and you want to debug this, right? But how do you do that? You could do TCP dumps, and you could do all kinds of things. But why wouldn't you use your program to debug these problems, right? You have everything that you need. You should have all the data in the program. So the idea here is we have Nginx, and the application server hides behind Nginx. Basically, it's proxied, reverse proxied. And so I need Nginx to give me more data so I can debug this problem. And so I told Nginx that Nginx should put port information, TCP port information, and the round trip time into some headers that I'll parse and work with this information on an ongoing basis, right? So, okay, I'll just show my notes. Okay, so what I will do, I will introduce just to simulate something, right? So you can see something. I'll introduce a new route, and this is all data that is actually running in production, right? This is code that is actually in OrgPad, and I'll introduce a new route. Let's say it's net info, and I'll label it as utils net info. Very, very basic, right? So, and I'll take this label, and of course I need to tell my handlers that there is a new route and that they should something should happen with it, right? So I write utils net info, and then I give it a function. I just give it the symbol, basically. So let's say it will also be called net info. Okay. And of course, I got the IDE tells me you don't have this function, right? So I need to implement it somewhere. And that's what I will do. I have something that looks quite similar over here. So I do the same for IP addresses, and so I will do something similar for ports as well, right? So I just copy the function, name it differently, of course, and what does it do? Well, I know the header is called X forwarded port, right? So then I get the request. So sorry, it's two screens, it's a bit difficult to navigate. I get the request right here, and then I do something to it. And this is this arrow that is so-called threaded macro. So what happens here is basically that the first thing evaluates and then gets put here, like behind the first argument, or before the first argument, so to say, right after a function call, and then this gets evaluated. So it's basically a pipeline, right? It's very handy because I don't need to read from the right to the left. I can read from the left to the right or top to bottom. So just to speed things up a bit, I will parse the address from using some other utility functions from the request, right? So that is, I have now the address. I want to. I was looking for the port. So I'll write in the port, and I don't have this function, right? So I need to implement that function to get the port. So what do? I switch to the other namespace, and I see here is the function for how to get the IP address, and I need to implement the port function. So I'll just, to shorten things, I'll just from my notes copy the functions in. You see that I basically look up the header, and then because port number is always a number, then I can just make it a number and not a string. So that is what I do, and these other things are basically the same thing, but for the round trip times for TCP connections. So okay, so now I have the I can send it to my REPL, so it evaluates, and I have it available. Client, and you see the IDE gives me these functions. Request, right? And then I want to have the socket address, and that is socket address, and inet address, and inet port, right? So what does this do? This is interop with Java. So inet socket address is something that is built into Java and enables me to make sure I have a valid IP and port, and it needs the IP address for that to work. So I want to know what type of address that is. If it's IPv4 or IPv6, that is just more information for my debugging. So I do that very quickly. Inet address type, and just get address and socket address, right? So that just gives me the address format, basically. And now I need to distinguish what type it is, and then I will just ask what object that is. Instance and inet for address, all right, it got edit at the top, inet address type, right? So if it's instance of inet for address, then I just return 4. If it's instance of inet 6 address, I will return 6, right? So now with all the information in place, I can return something, right? So this would be a bit insufficient. So what I do, I will return it as JSON, because why should I complicate stuff? JSON, CLJ, JSON. Now I can give it just a map of keys and values. Get host string, socket address, my port that I was talking about, that I didn't have before, and I can give it the TCP round trip time, and I just use here the other functions because I don't have to do anything else for that. So. And you should be able, in a minute, to go over to, oh, and I need to, of course, change this to application JSON, right? And so, of course, I now can send it to my REPL, and you should be able to go to a specific address and get the information, right? So let me send these routes there. I need to evaluate basically all these namespaces, and you see there is some state management already built in, so some things need to happen in some specific order, so that got all handled by the infrastructure for me. So I don't know, I don't need to know in which order it has to happen. It gets evaluated from my source code. And so just to check in the last minute, we can skip here, and basically I should be able, yes, right? So this, and every time I call it, I get a different number, you see, so it works, right? And it seems to use the same connection each time, but it just has some different parameters for TCP. So that's about it. A short example. I think we are about done.
We
right?
have 1 minute, so maybe if you have any questions, you can ask the speaker now.
It's all quite fast, I think. Any questions? In that case, I will show you one more thing. I thought that was all Clojure. I think for some of you it would be interesting to know how it looks like when you develop in Clojure script. And just a very short idea, I now have in development on my local machine this copy of OrgPad, one org page basically with one cell and one image. And now if I want to just get, I am connected into it, and if I just want to get some these units, what they look like, okay, I need to connect to it. Okay, so here you see that basically my Boromir is right here, and here I have the image, right? So the content is just some HTML image tag. Okay. Thank you.
Hello, I'm Eugene Srametnikov, and I'm a Strace developer, and I'm going to talk about netlink decoding in Strace. Probably everyone here who decided to come here familiar what Strace is. It's a diagnostic utility, a syscall tracer, but it's not only syscall tracer. It has some other capabilities, even though they're not so prominent. So, and this is mostly the result of the fact that interaction between the user space processes and the kernel is not limited by the syscalls themselves. And well, Strace, as being a debugging tool and a tracer, tries to capture as much as it can in terms of this user space kernel interaction. So, like, some of the items mentioned here, like dispatcher syscalls or IO-ring BPF, of course, themselves as syscalls. But the issue with them is that they're not like behave like some other syscalls. Basically, they do not impose any specific semantics in terms of the argument and leave it out to the rest of the kernel to implement it. Like the famous or infamous example is IOCTL that basically has no semantics, that's just a way to do something with something associated with descriptor. But there are also like dispatcher syscalls that are pretty much a kitchen sink. For example, FCNTL, it's mostly used for controlling flags associated with file descriptor. Also, it controls logs and seals associated with file descriptors, and some kinds of logs are not entirely associated with file descriptor, but the underlying file. The same goes for PRCTL, which is abbreviation for process control, and so on and so on. So, IO-ring is particularly egregious because basically it hides from this usual user space kernel boundary that can be expected with PTH syscall by introducing the asynchronous kernel ring mechanism that has to be expected in a different way. But we are here mostly talking about netlink, and it's probably worth noting why netlink is needed in the first place, because as I already mentioned, there already exists catch-all syscall, which is IOCTL, that basically provides ability for kernel developers, for kernel to provide any kind of service that is associated with a particular file descriptor. And by the virtue of issuing these file descriptors, for example, using special syscalls like perf, signalfd, what else? The memfd and so on, you can basically produce these file descriptors on the go and don't confined by those devices that are available via the DevFS, via/dev. So IOCTL is a vehicle that is used for implementing many kinds of kernel interfaces, like most of them, of course, device-bound, like various kinds of devices, like NTD, Video for Linux, GPIO, NBD, RTC, and so on. But also, as I mentioned, by the virtue of producing virtual file descriptors, some parts of the kernel that are not directly associated with devices can be also controlled via IOCTL, such as SICOM device mapper and so on. And that is actually kind of problematic. Well, it's not problematic per se, but the usage of IOCTL from both the user space side and in terms of kernel implementation involves dealing with lots of different kinds of problems that people most often are not aware of. For example, if you implement some IOCTL, you probably want you want it working on architectures that support compat processes. Well, the most notorious one is x86, but it's also ARM, MIPS, and several others. You probably want to have an ability to extend these interfaces. And don't add new ones instead of existing ones every time you need to add a new field or add a new flag, for example, because you forgot to check the remainder of the field, and since user space can pass garbage, it will pass garbage there, and you can't basically use this the remaining bits of the flags field anymore, for example. And all this knowledge is not part of any specification that is imposed by IOCTL. There are numerous guidelines like how use requests, how to implement IOCTLs, how to handle compat, and how to handle extending the interfaces, how to write these IOCTL interfaces and structures that are used by these interfaces in a way that is extendable. But there are still issues with that associated with using IOCTL. So, yeah, like people usually don't care about anything at all and just hard code IOCTL numbers in their code. That's all the bricks and power and so on. So one of the issues that Netlink addresses is basically trying to be a better IOCTL, providing a better general facility that allows various parts of kernel to implement the user space interfaces. By the way, how many here do know what Netlink is? Okay, so I don't need to explain what Netlink is. Great. Netlink does a lot of heavy lifting by imposing a specific protocol and structure, basically mandating that every part of the message has its type and has its length. So, and also the kernel part of Netlink has certain facilities in place for parsing and verifying Netlink messages passed by the user space. So even though it is a lot of boilerplate code, it is still it's still much better than IOCTL. So many interfaces, as existing one as well as the new one, decided to switch to Netlink, and basically there is a certain shift in the usage of Netlink comparing to IOCTL, for example. NVIDIA has switched to Netlink since Netlink was historically created as part of IP Route 2. It also uses Netlink instead of historical IOCTL interface and so on. So it would be nice for us to handle it, and it does since 2016. It's not a modern feature. It's exists for several years. It was implemented as part of The initial implementation was done as part of two Google Summer of Code projects, first by Fabian Ceron under the mentorship of Gabriel Vascar and Dmitry Levin, and then by Chen Jingpiao that has implemented, has created a lot of implementation for handling Netlink row protocol and the Netlink SE Linux and several other protocols. Yes. Yeah, and since then, basically, Netlink decoding implementation in Astray is maintained and extended as much as time and ability of the developers allow. So a bit about implementation. It's actually, there's not much to talk about because Netlink is pretty straightforward protocols that don't have much peculiarities. The probably one major wrinkle that S-Trace has that since we have a different way of handling memory because we don't have the Netlink messages in local memory, but rather retrieve them from the tracing memory. We have pretty elaborate error handling in this case, and instead of handling the full Netlink message at once, we retrieve it piecewise and handle possible errors that may occur during this retrieval and handling piecewise. So rather than rely on libanail and its implementation that basically allows you to pass a Netlink message and a set of attributes and get a table where you get all these attributes parsed. We perform some kind of progressive parsing using type-keyed decoder tables. So with regards to the testing, it is mostly done the same way as the testing of most of other parts of stress decoding capabilities, which is we synthesize some payloads we want to check parsing for and perform specific syscalls on Netlink socket. Basically, we write to the kernel this synthesized payload and check whether the way the message argument has been parsed is the expected way. So here's an example of this kind of parsing. As mentioned in this slide, we have just a set of various markers that aid this kind of testing because various implementators of Netlink interfaces uses various types and use this attribute types in various ways and devise different hierarchies of attributes, and as a result we have quite extensive set of parsers. And this is one of the simpler ones that basically checks whether attribute payload that is interpreted as an object is parsed properly by the virtue of trying to supply a shorter message, a message that bounds unreadable memory. So we here have on the second line basically unreadable memory, which is denoted by its address, and some successful parsing in the end. Here is an example of using of strace output when it traces SS, shows sockets binary that is part of IP route to program suite. And here you can see that even though I tried to turn it down a bit, it's still quite elaborate because, well, yeah, Netlink messages are quite elaborate. Some of them have quite extensive headers. So for the referential purposes, the associated message is illustrated on the right. But you can see here that we try to handle various kinds of attributes and various kinds of data passed, like internet addresses, big endian, well, yeah, big endian network order data, and this kind of stuff. The interface is not decoded because it's 0, but I don't know why it's 0, but yeah. Probably because the request didn't have enough flags. Basically, the same thing you expect from other parts of strace in terms of decoding capabilities. So let's turn for more interesting part, which is, well, when Netlink decoding is not so boring. It's not so boring when kernel breaks something. For example, one of SOCDIAG protocols, SOCDIAG protocol implementations, namely SMC protocol, decided after a successful implementation of IPv6 support of the protocol, being able to be tunneled on top of IPv6, decided to supply the address family it's tunneled upon as part of the inetdiag header, which is used by strace to discern which protocol the inetdiag message associated with, and basically it made impossible for strace to decode this protocol correctly anymore, at least for 3 kernel versions. The funny thing is, it's mostly went unnoticed initially because the main user of this Netlink protocol, which is SS, show sockets, it doesn't implement dumping of sockets for all protocol families at once. So it doesn't need to discern between messages belonging to different address families, but rather it performs dumping for each address family separately. It just ignores this family field. So another part is that most of the time you can understand how payload should be interpreted by looking at the attributes type and know where in the message you are, but it's not always the case because sometimes these attributes or attribute hierarchies are protocol specific or address family specific, and one way some parts of kernel implemented is to provide an additional kind or address family specification specific attribute that tells what kind of address family it is, which works nice when you just parse all the Netlink message at once, but doesn't go well with progressive parsing. So as a result, we have to perform some context tracking and pass this information between the decoders. Luckily, all the parts of the kernel that provide this information about type of about the protocol or address families that the attribute hierarchy associated with first provide this information about protocol, and then the rest that is protocol specific. So far it works well, but who knows how some kernel implementer decides to use it, because because there is actually other way to provide this kind of information and basically use this protocol as a type of the container of a method attribute. Unfortunately, at least one place that provides this information this way is has it botched, because almost all families except one do exactly that, except for IF-Breach that decided that, well, it has to be special and doesn't provide this hierarchy. And unfortunately, it can't be fixed because, well, Netlink attribute hierarchy is part of, well, UAPI, and you can't break a UAPI. So there is also some minor wrinkles in, for example, as I mentioned, since Netlink is a better IOCTL is supposed to allow Netlink interface implementers avoid all the issues associated, or most of the issues associated with IOCTL. Unfortunately, all this goes to wane once someone decides to pass structures as is as payload of Netlink attributes, which brings back all the issues associated with extending attributes, maintaining compatibility, handling variances between alignment of not naturally aligned fields on different architectures and so on. So, despite the fact that, well, it is more or less known, and these mistakes are way less often than they used to be, they still happen from time to time. Luckily, for S-trace, most of the time it is possible to at least discern between various versions of the structure based on its size, which is not always the possibility with IOCTL, because some IOCTL implementation, some IOCTL interfaces do not populate structure size properly in the IOCTL request number. Yeah, and another fun fact that some parts of Netlink interface implementation just ignores the fact that, well, Netlink attribute type field is 4 types and use it as array index. But okay. Yeah, so currently we have several protocols supported as trace. Probably most prominent support is Netlink route, but I'd say that almost all message types are supported almost fully. Like, we have some issues with here and there, for example, with some protocol-specific attribute hierarchies, but yeah, mostly associated with tunnels, yes. And SOCDIAC is not actually fully supported because there's like one attribute that is not properly decoded that is associated with protocol-specific socket information. But yeah, it's a good shape at least for these several protocols. There are of course many more, but well, it is there. So some fun statistics. I already have compared Netlink and IOCTL several times, and it's pretty much comparable in terms of decoding implementation. Like IOCTL decoders by far like most extensive set of decoders present in S-trace. Like they account for more than 10% of all S-trace's code. And basic Netlink decoding support actually is quite close to it. So as I mentioned, like we have quite extensive Netlink road support, and one of most prominent parts of Netlink road is Netlink road link protocol, set of messages. And yeah, it's basically the third largest file or second largest file in S-trace code base, right behind the main S-trace file itself and the file with utility functions. What pertains the future plans, basically one area where S-trace significantly lacking is support of generic Netlink. There are several attempts being made to support it, and coincidentally we've gotten yet another pull request basically this week. So it's probably can be addressed and paves the way for adding various generic Netlink protocols into S-trace. Another big area which is probably quite important is lack of proper Netlink net filter decoding, because while we support the IP part of IP route, we don't support much the TC and net filter type, net filter part. And since Netlink decoders are finally moving to some machine-generated code and machine understandable specifications, it's probably would be nice to support them as well. Similarly to the way we support generation of IOCTL decoders based on color-like specifications. And this is probably it. So, any questions? Yes, please.
I'm interested in how you generate the last exercise, the next one. The next one. You said the 1L game. What's that?
So it's a recent, well, relatively a recent, like probably 2 years. YNL is Netlink scheme based, Netlink schemes for various Netlink protocols that are written in YAML. So there is this is slowly going, like one part is describing existing Netlink protocols. For example, there is a lot of effort in fully describing KTH2, and another part for generating the parcels and handlers for this Netlink in the kernel. Because, well, as everyone probably knows, that Netlink decoders and Netlink parsers in the kernel have lots of boilerplate code that that can be easily generated, I would say.
We still have 5 minutes. Do we have any other questions?
Yeah, in continuation to the previous question. So, do you think if in the kernel they would use these generated somehow or interfaces, this would reduce the number of these oddities we in strays have to work around? And what could be done on to convince kernel developers actually do this?
Well, it's basically the same way as with IOCTL. Like the first, like several historical netlink protocols are handwritten and have all these peculiarities, and we basically have to live with them. But as the subsystem matures, it's more streamlined and newer. For example, generic netlink actually has some provisions, like has strict specifications how to handle structures, how to handle arrays, this kind of stuff, and provides specific netlink schemes that will allow this implement in the same way, in an extensible way. So basically, it probably will be the same as we have with IOCTL. Like we have some part that is historical and contains all these peculiarities, and we have some generated part that supports the newer interfaces and newer protocols. Okay. Yes.
With regards to the output, it doesn't. There are a few examples in the slides, and I must admit like for example, this one. I must admit it doesn't look that much comprehensible.
Yes.
What could be done about it?
Almost all S-trace output is currently tokenized. There are like several remaining bits, but there can be definitely done specific push at least to coverize that. And the next step is probably to provide additional information in terms of how, the next step is probably for decoders to provide additional information for output generators that can be used for producing more structured output. We actually have a pull request for that, but it again went nowhere. Yeah, probably third or fourth time. But yeah, I mean, it's gradually getting in better shape because like when it was first time attempted in 2015, it was basically a rewrite of each decoder in a structured way, and it was, well, unsustainable. Like right now, the latest iteration basically is pretty close to what can be done in a way that actually upstreamable. At least, well, the tokenization and colorization can be done. Like we can already almost everywhere, like there is some weird parts, for example, device mapper decoding S390 specific syscalls, ptrace commons that are not very well tokenized, but otherwise it's pretty much can be interpreted as streaming tokens at least.
Okay, if there are no other questions, I think we can wrap up the session.
Yeah. Thank you very much, and if you're inclined, there is some paraphernalia, stress them, so you can take it.
Morning, I was in another room and I explained what is Podman Desktop and what does it do with Container Engine. Not only Podman, because it works with Lima and Docker. And now I will go a little bit fast forward on all of these questions and try to do stuff with various Kubernetes, break stuff. Maybe some live demo will not work, but that's okay. Okay? I'm super stressed for the live demo, but that's the most important part. So, why we started Podman Desktop? So there is one thing is that Docker Desktop changed the license, and it opened the possibility to start a new project. That's one thing. But also, it's that with Docker Desktop and Docker Compose, you end up in development with something that you cannot easily deploy in production, and and even worse if it's if it's Kubernetes, it may not work, and if it's OpenShift, you're almost sure that it won't work. And so the idea is to shift less things, is that rather than having a container that works in development and then you go in production and you discover that it doesn't work, to give to the developer the possibility to test as fast as possible that what they are doing is working correctly on Kubernetes and OpenShift. Okay? This is another very beautiful thing. I'm not able to do a beautiful picture like that. So that's the idea. And the idea is that Podman Desktop is not only controlling the container engine, Podman Engine, or Lima, or Docker, but it's also playing with Kubernetes. And that you have just one click or a few clicks to do to transform what works on your container engine into something that works on Kubernetes. So that's the default dashboard, put in very small to see everything. One of the things that will happen next is redesign of this dashboard. Yes. Other reason to do that is containers are Linux. So, yeah, okay, you have Windows containers, but nobody uses them. And when you want to run containers in production, they will run on Kubernetes, and they need to be Linux containers. And on Windows and macOS, it means you need to run a virtual machine with Podman in it, or with a container engine in it. And yeah, that was not easy. So the first task of Podman Desktop was to build an installer that helps you install, initialize everything. It's not here. So we have installer for Windows and macOS, and so we have maybe 5 different installers for Windows. And we have one installer for all Linux. Flatpak for Linux. And for Windows, we have an MSI, an executable that you don't need to install, Shoko installer, Winget installer, and a fully air-gapped installer. So a lot of options. For macOS, same thing. We have an installer that works on multi-arch, and then an installer that works only on the Intel or only ARM. So that was the first stages of Podman Desktop. That was being able to distribute things and to install Podman Desktop and Podman everywhere. That's done. And it's stable, let's say. It's stable. It works. Now, we have some bugs sometimes, but the most of the bugs are not here anymore. Then feature run containers, so you can pull image, push image, build image, configure registry, and you can run Docker Compose. For the people who are behind the proxy, we have options also. That was something that we built in January, February. So you can configure a proxy. You can add your own image registry, and you can install in air-gap environment if you are in jail. And other thing, if you have already a Kubernetes configuration, you have access to it. So you don't need to. So if you already have your remote Kubernetes cluster, that's already available in Podman. Then the basics, I will go fast because I spoke of that this morning. So basics, creating a Podman machine, pulling an image, starting a container, building an image. If you want to go to the slides, you can look at it and you have small videos for everything. But I will fast forward on that, okay? That was the session of this morning. So this is where I will start from now, and I will try to make demos that work. Okay? So, who is not familiar with pods? Wow, everybody knows. So that's good. I will start from the situation where on Podman, so on the container engine, I have a pod running. And now that I have that running on the container engine, I want to push it to some Kubernetes. Okay? And so if you have already one Kubernetes engine configured, you can use this one. But then for a developer comes the moment to say, okay, I want to run my own Kubernetes, so I want to, but what can I do? What can I run? And we have started to create some extensions that help you initialize Kubernetes clusters. The first thing, the developer sandbox, it's OpenShift cluster managed by Red Hat, where you have OCP, the OpenShift Container Platform, plus some developer tools like Encharts, the Red Hat Builder Image Catalog, OpenShift Dayspace, and S2I. Okay, these things. So something in plus, and a lot of restrictions. So you are a developer, you cannot be an admin. After 30 days, your sandbox is disappearing. You can only work on one namespace, one project. You are limited in RAM, you are limited in storage, and if you start a pod after 12 hours, it's skipped. Okay? So that's, let's say, that's the trial, demo trial mode. You want to start with it, you test it, but you cannot really work a long time on that kind of stuff. Then you have the option to install OpenShift Local. OpenShift Local, that's another binary that you can install via a Podman desktop extension, a little bit like how you install Podman. And then when you have OpenShift Local, you still have to choose between two bundles, so two versions of OpenShift that you can install. You have one version that is OpenShift, just single node OpenShift, and where you have all the features that you find in OpenShift. You need, I don't care about that. You need, so you need quite a lot of CPUs, so quite a lot of resources. But that's, at the moment, that's what is working well, the best, if your laptop is strong enough. And then we have Microshift. That's only networking, ingress, storage, Helm, so nothing else from OpenShift. That's, let's say, yeah, that's like the container engine plus networking, plus ingress, plus deployments, but quite restricted. And that's a very cool solution, but it's very young. So at the moment, we have some stability issues with it. I believe the first version that's working has been out 2, 3 weeks ago. But that looks great for the future. You know, if you don't want to, just because you want to test things work on Kubernetes and you don't need monitoring, that's a good option. And last option is Kind. Kind is just Kubernetes running in a container, and that's the first thing that we built. So in Podman Desktop, that's the first plugin that we created, and that's the It should have been the first demo that I make, but it's broken. No, on my machine it's broken, and I cannot start a rootful Podman. So rootful Podman is completely unstable on this laptop, and I don't know why. So developer sandbox, should I do the video?
Yes, please.
Or do the live thing. Huh? So the developer sandbox. That's the console of the developer sandbox, and that's the console for OpenShift local. So they look quite the same. So developer sandbox, I have one project here. I cannot create project, and now workload. It's empty. I'm not cheating, huh? And now I will switch my context to my sandbox. First showing that here I have a sandbox in unknown mode. That's not good. Ah no. Good. It doesn't work. I will do the demo afterwards then. The problem is I started my laptop without the network. Podman Desktop started without the network, and things are broken. So let's start with the demo on OpenShift local, and then I will restart Podman Desktop, and hopefully it works. Okay. So on OpenShift local, you have two profiles, an admin profile and a developer profile. And last time I tried with the developer profile, I could not do everything I wanted. So let's try safe with the admin profile. And on OpenShift local, here I am the admin. And let's try something that I've never done. is how to create how do I create a project? Ah, yeah. Voilà. So now I have a project that is entirely empty. And entirely empty. Where is the rabbit? Not in my pocket. And I have my pod now. And I will deploy to Kubernetes. And now it's asking me to deploy in the Kubernetes context. And I can choose my project, which is the last one, that's good. Hop. And let's try it. It worked. So I have my pod running here. I can see it in the console. If I look here in the Podman desktop, I see here that I have this. It's good, big enough? Yeah. So this pod is running in the Kubernetes in the context CRC admin. Okay, the namespace is not displayed here, so that's some of the, I don't know, some of the things that may change in Podman Desktop at some point. It's that the interface is super simplified, super simplistic. So there are things that we don't show. We don't show the namespace. The context is in the sys-tray, so you don't see that in the interface. And we don't show deployments. We show container, pods, image, storage, and that's it. So for for an advanced usage, it may be not the best tool. But if you want just to move things from your container engine to Kubernetes without even thinking about it, and then you give the work of fine-tuning to other people, that's very good. So I see my pod here on the Kubernetes. I can see the logs of all my containers. Yeah, that's good. So search doesn't work here, but here search does work. So that's one of the hidden features that I have to show is if you click in the content, you do Control F and you can search in the content. That's very useful. And now that you have something that you know that works on Kubernetes, same thing. You can copy the YAML and you put it in the code that needs to be deployed. And voila, that's done. Maybe you have to clean up some things, like the IP address. I'm not sure you have to put it in the code for real, but you have already something usable, a good entry point. Another hidden feature, when you go to the summary, you see that you have your containers, and the question is, how do you access to the app you deployed? And oh no. Because I believe that will not work. Okay? Oh, I guess it works. That's perfect. I'm not sure it's the right one. Okay. Let's stop this one. Okay. That was the application on the container engine. Okay. So that's one of the things that are still a little bit tricky now. Is now I have my pod running on my Kubernetes, but how do I see the app? And it's not something that is easy to do at the moment. So I had a question this morning about the evolution and the things that need to be better. This thing, for example. So this is leading me to something that is not the right thing. And at the moment, the only way that I know is to go to networking in root, and then you have your application that works. Okay. I can take a question at this moment on the source. No question? Okay. Installing OpenShift local. Let's look at this. That's not something I do a live demo. It takes too much time. Has someone already tried to install OpenShift local before? Or not? And?
It worked.
Was it simple? How much time do I have?
12 minutes.
Before the questions or before the end?
Before the end.
So 2 minutes before the questions.
You can take as much time as you want.
Okay. Okay. Then I have kind and okay. Let's try. Let's try to see if I quit Open Desktop, start it again. If now my dev sandbox is fixed. Windows. I forgot to say, I've been using Linux for 25 years, and for this project I'm running Windows. So it's still a no or what? It's question time. So okay, let's delete it and rotate one. So the name will be my sandbox. I'm already in it, so I have just. That's the sandbox. Copy login command. Login with the sandbox. You will see my token. I copy this line. So that's the things also that are now that require still a little bit of manual work, but it's very difficult to retrieve the information automatically. Maybe we will manage one day. And I paste my login command. And now, is it working? It's exactly the same as before. It's just I started without network. So now I change my context to my sandbox, and I will. So I change my context. So now I don't see the pods and the containers that are running in my other Kubernetes context. So sometimes it's confusing. So you always see the container if you're in your container engine, but you see only the things that are in your current context for Kubernetes. So now I don't have access to the other one. I will deploy this one to Kubernetes. It's exactly the same thing, but it's in my sandbox. And let's see how it works. And now, if I go down, I have my pod running. Wonderful. But this time it's not local, it depends on all the network. And now I can take questions, or I can fail instantiating a kind as you want.
Okay, so I have a question. How much inroads do you think has Podman made in the Windows world?
Can you repeat?
So how far has the awareness gone regarding the availability of Podman somewhere else than on Linux, if I can rephrase that maybe?
The availability of Podman in Linux compared to what?
No, on other platforms. That's what I'm talking about. Like, Podman as code is not just targeting Linux, right? That's the whole point.
So Podman desktop is more for Windows.
Exactly. So I'm
So
wondering, like, how
I have to repeat the question here. That's it. So the question is: Podman desktop is more targeted as Windows and Mac user than Linux.
Kind of. I'm wondering, like, how many people are actually installing it on Windows?
I don't. We have metrics on that. I'm not sure they are really good because you have to. You have to allow for metrics collection at the beginning. We have very few Linux users. And then, let's say 2/3 Windows, 1/3 Mac, and 2% Linux. So that's really not a lot Linux. But we believe also that the proportion of Linux users to say no to data collection is higher. So that's what we think. And we think also that on Linux, you can install the text user interface. You already have it, so you don't need it to install Podman. So it makes that people who use Podman desktop just to install Podman are not users on Linux. So on Linux, the only reason to install Podman desktop is you want to do this container to Kubernetes, which is really a cool feature. Or maybe if you want to visualize your containers. I like it because it's really good, nice for me to visualize things like as container pods, images, and I have an overview of everything that is there. I like it a lot. To prepare this presentation, I have destroyed my Podman machine 10,000 times. So the fear of starting from scratch and starting over is gone, and it's this. And on Linux, I never prune my image, so I do it when my disk is full. So it's I don't have the same way of using Podman now on Windows and on Linux before. So it's changing the behavior. I don't know if it's for good or not, but I tend to be more tidy with Podman Desktop because it's cluttering the UI, and it's like, I don't need this image, click, 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 click. It's faster than just than writing the command line or making a script to say, hey, all images I didn't use since 2 months.
Just typing in system tool.
Yeah. And but there are also quite some features that don't work well on Linux. For example, the proxy. The proxy, the feature that is made in Podman Desktop is made to inject the proxy configuration into the Podman machine using the Podman machine API. But on Linux, you have your local Podman installation, so you don't use that. So you have to edit your config file by yourself. So that's something that really. Now I'm running Windows because when the feature doesn't work, maybe it doesn't work because it is on Linux because it's an edge case. And I don't say I am super happy with it, but that's like it is. Other question? Out of time or not yet?
We have 3 minutes.
3 minutes.
So if you have any questions.
You have more questions? I can fail a kind installation if you want. So, most probably, it will fail. So on Windows, when you want to create a kind cluster, you need to have a rootful Podman. So when you do a Podman machine installation, normally it's rootless. Just if you need to run kind, you have this kind of errors, and since this week, so just this week on my machine, I cannot start. When I start a rootful Podman machine, this machine is just completely flaky. So it's I cannot see the containers. I don't know. I don't know what's happening.
It's Windows, that's why.
Yeah, maybe. And someone asked me this morning why. So what I think about CLI in Windows. So in Linux it's straightforward. In macOS it's straightforward. In Linux you have different terminals, but it's the same shell. And then we can talk about bash, ZSH, etc. But in Windows, for a starter, you have to choose which terminal do you want. Do you want CMD? Do you want PowerShell? Do you want a bash in your Linux virtual machine? Do you want Git bash? Do you want a PowerShell but in administrator mode? So that's just running CLI tools in Windows it's still a mystery to me. It's like, okay, here I can run this command. Yeah, it works well on Git bash, but then it doesn't work on CMD. It doesn't work by design. So Windows users are not doing shell because they don't like shell. It's because that it's just
It's broken beyond repair.
I'm trying to do, I'm the tech writer for Podman Desktop. I'm trying to run Antora and to do usual tech writer stuff, and doesn't work. Out of time.
My name is Renaud. I'm a software maintenance engineer at Red Hat since 6 years. And if you didn't guess from my accent, I'm French. So as a software maintenance engineer at Red Hat, I'm specialized in RHEL, and I'm dealing most of troubleshooting customer cases that are related to user space. So services that can be systemd services, systemd, YUM, YUM DNF, rsyslog, so a lot of things. And usually, to troubleshoot issues, I love to use strace. And I will tell you why. But because this talk is for beginners, I will go very simply on explain you how strace works, when strace can help you and when it cannot help you. And basically we go through dissecting what strace outputs, and I will go through examples of 5 or 6 cases where you can use strace and how to use it. And finally we will wrap up with some SE Linux integration stuff. So what is strace? So for the guys that already followed the strace sessions, they know, so please be quiet. strace is a tool that enables you to see which system calls are executed by your program, your user space program, and prints back their value. So it works, you can have many options. Below are the options I'm using. For example, I'm always using -f flag to follow forks. That is when a program spawns children or spawns threads. I'm using TTT to print various timestamps in human readable format, I would say. So some hour, minutes, seconds, milliseconds, and then delay in the syscall. I'm using V because I like to have much decoding of the syscalls. S to specify the buffer size of strings, and YY to decode more stuff, basically. And when you want to attach to process, I will show you that later, of course, you can use pflag. So strace is, I said, it's all about syscalls, but what are syscalls? So basically, so syscalls are a way to interact between your user process and the Linux kernel. There are other ways, but I won't tell here. So basically, every time a user process requires access to a resource, it uses a syscall internally. And this syscall is wrapped in a glibc function, basically, for error checking and other stuff. For example, when your program, which can be C or Python or anything, calls open, you have it internally somehow will call sysopen, which is a syscall associated to that. Usually there is a simple mapping, but not always. For example, when you create a child using fork, it's not fork that is used anymore, it's more sysclone. But, well, you can have a list of all the syscalls available on your system using syscalls to man page. So when I put that in brackets, that's the man page, the section, and you have a list. It depends on the architecture. And when you want to do more about the syscall, so I just show you that you just use man on section 2 and then the name of the syscall without the sys underscore prefix. So how does it work, strace? So strace uses the ptrace interface internally, which somehow sets a breakpoint on the process that you are monitoring, that we will call callee. So every time a syscall is entered, the callee stops and strace gets a notification. Strace collects the data it wants to record for you, for later, and tells the callee to continue. The syscalls happen in the kernel. Upon returning, the callee stops again. Strace collects the rest of the data For example, the number of bytes it wrote to the file system or stuff like that. And strace prints you back to standard error or usually to a file some nice lines that will help you troubleshoot usually. One thing to note is that you cannot have two callers of the ptrace interface at the same time. That is, if you are already attaching the process to GDB, you cannot strace the process you attach to. Usually it's not. It would be nice in some cases, but well, it's not the case. You cannot do that. So when strace helps, but basically it helps when syscalls are involved. If there is no syscall, it won't help you. So basically you can have command hangings. So by hanging we say you start something and it waits forever, you don't know where, it prints nothing. So that's a command hanging. Program waiting hanging, that's almost the same, but usually it's more when the network is involved, for example. You can use the strace to find, when you don't know a program, to find which file is processing, opening, reading, writing. That can be very various things. It can also help you see which libraries are linked to the program. For example, if some customer set LD library path, you will see that other library can potentially be open and be used, and that make your program fail later. And also, if you know nothing about what you are trying to troubleshoot, you can also perform some kind of reverse engineering of the communication between the program and the rest of the world. Last thing is you can sometimes understand what triggers some specific error, but usually you have to check with the source code and try to first to match where the source code is and get more. So more use cases, but that are the use cases I'm mostly dealing with. So as I said, strace is of no use if there is no syscall at all. So if your program is just spinning on the CPU, there is no syscall involved for that, it won't be of any use. If a syscall is not returning from the kernel, so hanging in the kernel, it won't help much. It will just tell you that when this syscall with, for example, this file descriptor or this file is being called, you hang forever in the kernel. So in such case, you have kernel tools such as tracecmd that can help. It's more touchy, and it's kernel things, basically. strace may not help you when you have some issue related to some race condition. For example, you have your program with multiple threads, and something is misbehaving. Usually, stracing will hide the problem, which gives you a tip that potentially you have some issue with some race condition, but that's all. Of course, when a program dumps core, strace is of no use. And when a program exits just because it wanted to exit due to some internal computation, it won't help you, because you need always syscalls to be involved, basically. So recommended usage is not really recommended, it's my recommended usage. That means that when my colleagues ask straces to customers, but they don't want to analyze the strace by themselves, they send it to me, and I like that they use these flags, basically. So strace has a lot of flags. I can't tell how many, maybe they are useful stuff, but not for me. Actually, I didn't read all the man page of strace yet in 6 years because it's too long. So there are too many possibilities. So when you want to strace a command and it's run, you use fttt vyy, for example. -o will store the result to a file. -s, which is 32 by default, is how long the strings strace collects. It's collecting. It's 32. It's too small to me. Usually now I use 1 to 8 Here I put 1K, it's good enough, but sometimes it's, well, the larger you specify this, the bigger the trace will be. And once you have gigabytes of just one file of trace to analyze, it's not that optimal. So usually to my peer I say 1024 and it's good enough. You can trace. So first case was I start my command under trace. The second case is I want to attach a trace to a specific program. The difference here, I'm not sure that will work, so it's using -p. -p, you can specify multiple processes. Just be aware that if you attach to a program and the program already spawned children before, of course you won't monitor the children. When a process gains root privileges, for example sudo, don't forget that to run strace as root already, otherwise, of course, you won't see anything once the program became root. So for me, for my job that's easy, I always do straces using root, whatever the problem is. So now that we have the basics, let's see the output. So the output depends on the flags you use. So for all these outputs, it's FTTT VYY. Okay? So first you have the PID. The PID is the thread ID of the program that you are stracing. Then you have the timestamp with hours, minutes, microseconds. Then you have the syscall name and the syscall parameters. And then at the end of the line, you have the equal sign means the syscall returned, and you have the result. So the result is dependent on the syscall. Can be 0, can be something else, depends on the syscall. And at the end, very end, you have the time spent. So I think that is a big capital T here, but I'm not that sure. So here, for example, in that example, we enter the people syscall, which was waiting on some descriptors, and it returned on timeout after 900 milliseconds. For those that use VI, you can set a strace file type so that you get some nice colors. That's it. So 2 examples here. From time to time you get, well, it's not from time to time. Usually you get unfinished resume thing. So basically, in the previous example here, we had the syscall on one line, one after the other, but it's far from being always the case. For example, you will see this kind of thing. So the PID, the timestamp, the syscall, and unfinished, and later, in some other line, you get the result. So this happens when you have a multi-threaded program, usually, or you are monitoring more than one PID. So that's completely expected, but it can make analysis difficult. I think there are some tools available on the strace website to pack things, etc. But honestly, I'm never using that. Strace, so many syscall return -1. -1 is usually an error. Is that bad? Well, it depends. There are many syscalls that are designed to fail in error. For example, when you try to access a file and the file doesn't exist, it will return -1 and set the RNO, and the RNO is set to no such file directory, so INOENT. So for usually the RNO that you can skip, and because they can make you think that reading SOS is difficult, are E again, E interrupt, E restart sys, and E restart noend. INOENT, no such file directory, usually it's perfectly normal, except, for example, if you try to execute an executable has been through and doesn't find it, and so here in that case, usually the shell will try multiple location if you use just foo as the executable and not the full path name. It will try various places where to find the program, and in the end may fail or not. Another example, the program tries to open some library which doesn't exist. It says no sulfide data, but it continues, so there is likely no issue. Real issues are usually when you get EPERM or E-access, which means I couldn't access the resource. Something I didn't tell is that strace also catches signals and it prints which signals were received by your program. So here in the example above, we see, for example, that PID 6138 was doing a select, so it was waiting for something on the network, for example, or just sleeping, and it got a SIP kill, so it was killed. And that's it. You have other examples with SIGTERM, SIGSEGV. SIGTERM, it gives you, so when strace processes the signal that was received by the callee, it prints you details because of the -v, I think. So here, typically it says that you have SIGTERM received, and it was from the user space, so some other process. And here it prints who sent SIGTERM, that was PID1, so system D, and then how it was running, basically, so as root. Sometimes you get signals from the kernel, for example. So here, that's the case where the kernel killed the program because of a segmentation fault. So and there was, the program tried to access address null. So it was a null pointer dereference. So strace shows you a lot of things that are very interesting to troubleshoot, basically. So let's go to the examples. So I have 6 examples, basically. So, stressing a command slowness. So typically, so I see that all the time at customer systems. Basically, they execute a command and it's slow. It works, but it's super slow. It takes 10 seconds. With strace, it's very easy to see what's going on. So in that example here, we were executing DF, and because execv syscall also knows the environment variables and all that stuff, it prints the environment variables, so I skip it. And we can see, for example, that this DF program had in the environment LD library path set to some SAP directory, which is not an issue. So you can check the man page from here and see how this was, how to match between the things. Yeah. So here we have the path name, df, then the arguments, df-a-h, and then the rest is environment. So it's in brackets here and it goes to the next. So when you see something, this is a real example, basically in the program. So it was taking a long time, so 10 seconds to execute df. And for strace, we could easily see that it was processing the LD library path because it tries to open libc in various locations, which it couldn't find, which is not a problem because LD will then try other paths. But the issue was on the time spent to find out that there was no file. 400 milliseconds to scan a location. At that time, strace is of no use anymore. But you know where to dig into. Basically, you have to check why accessing USR SAP fails, but takes so much time to fail. And basically, for the small story, it was failing here because of some automand that was happening in the background and breaking. I see that I don't have the complete presentation. Too bad. Okay, another use case is stracing SSH being slow or hanging. This happens all the time. When doing so SSH, you need to remember that you have two parts. You have SSH and you have SSHD on the server you are accessing. Many, many times I see people sending me traces of SSH. As such, SSH does nothing. It just connects to the server, and that's the server that does the job. So always remember to trace the server inside, instead. Usually I now ask also to trace the client so that it's easy to match the timestamps and to see the connection, the port being used and stuff like that. So how do you trace the server, SSHD? Well, I give you some tip here. Basically, I get the PID of the SSH server, which is Andwell and Fedora var run sshd.pid. I trace. I start trace. I tell the customer to do the SSH, and then to control C trace once he considered that it was too slow, basically. And then I check it. The other way to do that is to, that means that trace will trace all the activity of SSHD. So all the connections, even the one you are not interested to. So sometimes I ask the customer instead to spawn a new instance of SSHD just on a specific port, 8022, for example, and connect to that. But I don't like that. I don't do that much because the issue is that you need no firewall and no open port and SC Linux to be configured to allow that, and etc. And finally, so we get our trace from the server and we check it. So initially we search for accept. Accept is a syscall to accept a new TCP connection. trace shows you all the details. It shows the port on the local system, so it's on the client, and it's always 22 here because it's our SSH server. And some lines later, we see a clone. So basically, we have SSHD fork a child to handle the connection. So search for this, search for clone, and once you have the clone, you know that you are interested in this process and its children. But usually, there is no need to check for the children. It depends where the issue is, but basically, you extract from the biggest trace you have all the children, the PID 23918 and all the children, and then you can dig into that. So I'm giving you some, but I have better since then, but basically, that's the thing. If you use the SSH listening on alternate port and just listening for one connection, there is no clone because it's a handler that will, the SSH service just for one connection that will handle the new connection. So what we have here? Well, that's a real example. So sometime later in that trace of our SSHD connection, we can see that some message is sent. This is a dbus message, create session, blah, blah, blah. So this is PAM systemd running to create a session for the user. No issue with that. So it's sending, and then it answers, it waits for some answer. The initial answer is again, which is, hey, I have nothing for you, because I'm in non-blocking mode, I return immediately. And then we can see the code doing a people, which is basically waiting for getting a notification that there is something to be read on the file descriptor which is used for the connection to dbus. From there, so we know that, and we could see that the poll syscall failed in timeout after 25 seconds. Once you have all this, you know that you are done. Basically, there's some issue sending the message to systemd to create a session. It waits for 25 seconds, and then it continues. Then, of course, you need to know some internals that SSHD internally executes the PAM stack, and in the PAM stack there is PAM systemd, which is responsible to set up the session, etc. So basically here, there was no connection to systemd login, which is in charge of telling systemd to create the session. Stressing sudo and su, so program that become root, you have to proceed differently, because as I said, if you are not root already, when you execute strace, you won't see anything once the program becomes root. So what I do is I strace the shell that the user will use to execute the sudo command. So I use echo $$ to get the PID, and then I attach strace to $. I tell the customer to execute his command that fails or is slow. Usually we use sudo su, which is a bit redundant, but that's alive. And we get some strace. When you want to strace a debound, for example, cron, well, you can attach to it and wait for cron to execute, basically. So that's very easy how to manage things. A common mistake is similar to SSH, is when you want to strace a failing systemd service. So I see people all the time stracing systemctl command, which basically does nothing as for SSH. It just talks to systemd, and systemd does the work. So to have something useful, well, you have to strace systemd. So PID 1. So procedure, you strace systemd, you start the service, you control the strace of systemd once you consider that the service failed, and you check you try to extract from the biggest trace you get, because systemd was doing other things, what is interesting. So what is interesting when you have to find when systemctl was executed, basically, to say, hey, start this service. Well, how it works is very similar to SSHD. You have some exec4 syscall on the socket, on the Unix socket, and later you see systemd creating a child for cron, and later, again, you see systemd, so it's a child of systemd, executing your service. In such case, rsyslog. Basically, you will see as many exec VE as there are, so as many children as well as there are exec start pre and exec start commands. Then you need to extract. I have better tools, as I said, with grep, blah, 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 and then you can dig into what you want. That was ancient times, so I was doing all manually. Now I scripted everything. So basically, you get the child of systemd, and all the child of systemd you are interested into, and then you recursively extract all the children of your service. In this case, it's spawn. You can easily check using the strace as well if you could see some process or some services being killed or that failed with error or no error by just breaking, basically. So some people will say, yeah, okay, you do a US thread systemd, you get a mess, and then you do filtering. Why doing that? It's because, well, there is another way, is to hack the service unit and just replace rsyslog here by strace your command and rsyslog. But that's bad. That's bad because on RHEL you have SC-Linux, and because of that there will be some automatic transitions happening. We have strace being labeled with bin_t, and systemd execute as init_t. So when systemd force the child and start executing strace and not rsyslog, you will become, so strace will become unconfined service state. And because of that, strace will then start rsyslog, and rsyslog will run as unconfined service T, which is not appropriate for rsyslog. So probably your service won't fail because it's open bar, let's say. Whereas for rsyslog, which is supposed to execute in syslog DT context, it can do less. So that's why never hacking the unit type and just relying on stressing systemd and then filtering. 5 minutes is perfect. So, stressing boot activity. That's very similar to stressing systemd, basically. This happens, so I do that rarely, but from time to time. I want to stress the entire boot activity when I have no choice. Basically, I can see for time to time that a service fails to start at boot, but once you restart it, it works fine. Why? It can have many causes. Usually, it's due to when you boot, you have no network. If it's a service that starts early, you have no network, or you have no DNS resolution. You can have the network, but still no DNS resolution, and stuff like that. So the easy thing to do is strace systemd as soon as you switch root, so that you get everything. Of course, your system will start slowly because strace has a huge impact, but you get everything. And then you filter and you're good. So this is a small trick to do that. You will mount, because after just switching root, you have nothing. So first you boot with init/bsh, so that you get the prompt at switch root. I remounting / with a read write, and then I execute strace, but somehow specially with capital D, so that it becomes the grandchild. Why? It's because we want to have systemd be PID1. If we were just doing strace blah 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 systemd, strace would be PID1. And this thinks that it works, but in fact, because PID1 is special and is used to reap processes that have no parent, it won't work. So use this, start it. So you will have your nice systemd running and all the children, all the services, etc. And once you can log in, you have to kill strace forcibly. Otherwise, it doesn't work. I didn't check exactly why. I think there must be some signal handling issue, basically. And last thing is on SLLinux integration. Dimitri already said it yesterday. So with recent strace, you have SLLinux integration. That means you can see, that's very interesting when you want to learn SLLinux, you can see transition happening when you execute services. This is an example with rsyslog. When you put --sc context with nothing, you have very small things, very small indication here. We can see that the child of systemd that will execute rsyslog, which is this PID, initially execute in the context of the caller, which is systemd, so init t. And then it tries to execute rsyslog, which is labeled differently with syslogd exec t, and this results in the next line, when execv finish, this result to change context to syslogd t. So if you start stracing with SC context by hacking the service unit, you will see that you won't get this at all. You will become unconfined service T, which is bad, basically. So it's on Fedora 36 and later, RHEL 8.4 and later. And for ancient guys that do not have this, I have on my public space some rebuilt version of strace, the latest at that moment I did. So it breaks a bit, but with SC context integration there. So it breaks because some decoding is not aligned with the kernels, but that's of not much interest. And that's it. I'm done. Questions? Looks like you are no beginners.
I just want to be sure that everything you did is upstream, right?
What?
You provided a link to a separate
Yeah, that's just I use the upstream S trace and just rebuilt it for SC context. Yeah, so it's just private binaries that I give to customers sometimes when I need that on Rails 7, for example. No question? If you have question, you are shy, you can we can talk later.
So for the early boot integration, you write to a file. But is there any way to, for example, if I'm booting in a VM, is there any way to like get S-trace to just write to the serial bus?
Oh, so the question is, I'm writing to a file when I want to trace the boot activity. Could we do that through serial console? Well, yes, you can, because I think the serial console is already set up in /dev, so you can stream it. But, well, writing to serial console is never good because it's super slow and it's synchronous. So writing to a file is nice. And also the files will be huge because you have maybe 30 or 40 services running initially at boot.
I actually heard yesterday somebody suggested to create a memory device, and so mount interface.
Yeah.
Story.
Yeah, that could be nice. Yeah.
So not to touch root file system.
Okay. Yeah. As long as you backport it to Rails 7, that's great. No? I'm interested.
Okay. I suppose TeamFS is supported here and there.
Okay, that's it.
Thank you very much for
Start. Good afternoon, everyone. Welcome to DevConf.CZ. I am Rajan Umman.
I am Navinesh Inde. We are part of Developer Experience Engineering team in Red Hat.
Yeah. Yes? Okay. Thank you. Yeah. I would like to start with this quote. In 2011, Mark Anderson quoted this in the Wall Street Journal. He states that software is still eating the world. So basically, his idea was like, day by day, our daily problems are getting solved within the softwares. Everything is getting resolved within a software ecosystem. Yeah. So there are a lot of innovations which are happening right now in the industry, like ChatGPT, e-commerce applications, a lot of things which are happening right now. So how are we managing this? How are we managing this innovation in an engineering perspective? Innovation is good all the time, but how are we managing as an engineer? Managing the innovation means, are you able to track the good things in the terms of good practices and all? So basically, my point is, every day that whenever the new innovation happens, like the stack is always, the problem stack is getting more complex day by day. And like in an engineering perspective, software onboarding, the collaboration, management, everything seems to be different day by day nowadays. So it is good that we should resolve this kind of things actually. There are a lot of problems which are coming right now. You can see some collage on my screen. In the collage, I have tried to address some of the problems which come in my mind in an engineering perspective. When you develop a software, deliver a software, managing a software, a lot of problems will come to you. Some of the problems I have addressed here, like for example, consolidation of the efforts. That's a major thing. So something can be the management, something can be the templatization, better software management. A lot of problems are coming in the picture. So in the current scenario, many organizations want to achieve more with in the rapid delivery model with the less resources. That's a lifestyle which we are into. Who is going to take care of us? Is someone? Okay. So basically, in the engineering perspective, so as an engineer, I have to develop some feature, or I have to build some code and deliver it to the production, and I have to manage it effectively. That's the basic fundamentals of an engineer, like how to do the things in a better way. So engineers are actually struggling to make the things engineers are actually struggling to meet the technical depths, features, and everything, but we are not getting the right time. So these are some of the problems which we are trying to address here right now. And this is actually leading to us right now. We know everything. As a developer, I am developing the applications, I am maintaining it, I am putting it into production, but that is not the supposed job of mine. It is supposed job of a DevOps or a system administrator who manages infrastructure. I am being the jack of everything, but I am not being the master of anything, or in an engineering perspective. I am working on everything right now, but I am not a master of anything. That's a primary problem for the developers now. So do we have a focused solution which we can see every efforts in one place? Yeah, that is Backstage. So Backstage is an open platform for building the developer portals, which is homegrown in Spotify as an internal tool, and it is open sourced in 2020, and it is donated to Cloud Native Computing Foundation. Spotify enables the developers, engineers, managers, whatever the profile is, like what you will get to know the insights, like what is happening in your organization in a consolidated view. And it has a huge community base also across the world. This approach actually easified the life of the Spotify. Spotify has almost 1,000 plus microservices and the software pieces scattered across their organization. But with the Backstage, they were able to handle it. So this developer portal enablement helps them to track every pieces of the software which are scattered and everything into one single view. I told you the developer portal. What is developer portal? Developer portal is nothing but an internet for the developers, and it is a one single front end for our organization to handle all of our services or our software stacks. So it unifies your toolings services, softwares, everything into a single stack. So a developer portal primarily integrate the tooling, services, and the documentation also, which is a pain for us to manage. Also, we will get to know that like who owns what. Like we will get to know some insights on the like who is taking care of what. So there are a lot of insights when we'll get after connecting the Backstage with our software ecosystem. So that we can give some time to our developers that okay, you focus on building some feature. We can track everything in one place. Like if something goes down or something goes there, like we'll be able to track everything. So we can make our developers to work on in a focused mode. Yeah, Backstage actually enables the better collaboration, and it unlocks collective potential and empowers team to do what they do best with the speed and the scale and house control. So Backstage helps you to deliver your software and manage the software in a with the golden path practices. So Backstage it aligns the distributed culture of an organization, and it will helps you bringing all together into a single platform. Yeah, the core philosophy of Backstage is actually it acts as an interface to unify the things all together. I have mentioned this before actually. So it helps to build the single source of truth for your organization, and it will keep up your autonomy in your software stack. Like autonomy means like different enterprises works in a different model. So within relation to that, you will be able to see that how your software stack should be set up over there. Like you will get some insights over there right at that moment. So, and regarding the ownership, you will be able to set up the ownership for your Backstage components. For example, if I have a front end and he owns the back end, for the front end, I can set up the ownership for myself. For the back end, I can set up the ownership for himself. So we'll be able to track that, like who owns what. Also, this empowers the responsible software development ecosystem also. Let's go through the three core terminology of the Backstage, which is core, app, and plugins. Core is something like how the kernel is for the Linux. So with the core, like it is maintained at the Spotify. So it powers the basic functionality for the Backstage. App is something like we do something like a Linux installation in our machine, how it helps in our day-to-day activities. So app is just an instance of Backstage which is deployed, and we can tweak according to your needs actually. Plugins is a cool feature of the Backstage that we can extend. We can give the extensibility to your code. So for the enterprises, we can adopt the Backstage in their own manner. Yeah, Backstage actually helps you to create, manage, and explore the things. Creating means that you can build your software stack in an effective way. You can manage your software stack in a one centralized location, and you'll be able to connect the pieces across it. So by connecting means that like your data is shared across the organization so that the discoverability of your tools and services will be huge. So software model, talking about the software model. So this is a way where we classify our software components into one. So in this core entity, we are trying to classify our software, right? How our front-end system should work like, how our back-end system should work like. So we are classifying it into our, like how we are classifying into our software system like that now. So regarding to that also, there are many relationships also we can able to manage. Like you can relate your software one component to another component, how it talks. So for example, I have a backend system, I provide an API, so we can build the relations on top of that. Also, we'll be able to use the annotations to, we can use the annotations to extend the backstage actually. So it uses the Kubernetes format to define the annotation, so it will helps to extend your backstage with the, and use the plugins also. So it is a very good thing. One thing we can do with the backstage is like with the docs. So docs is always a main problem for the developers. So managing the documentation, for example, if I am an engineer, if I want to find the technical docs, user docs, like I have to go to multiple places and the multiple resources. So right now, with the power of the backstage, we'll be able to find everything in the one place with the power of the tech docs actually. And you can manage your content in the terms of markdown, and you can able to find your services with the power of the search. Search will be able to do your search will be able to search will be able to make sure that your content is shared in the backstage environment. So it is discoverable basically. Yeah, search itself, it will help you find out the content. So with the search, by default, it is a memory search mechanism. So it is able to connect the software pieces across the system. If you search for a software template, you will get it. If you search for a documentation associated with a software template, you will get it. So it's already there. And good part of that is by default it has an in-memory search, but also it supports Elasticsearch, Lunar, and Postgres as their backend search engines. And this is suggested for the higher level usage actually. In-memory is not a good search mechanism in the terms of a large scale usage. So switching to the search engines makes sense actually. And it helps to communicate within the service to service plugins, and you can customize your search experience to your people. Yeah, I'm handing over to Navinya.
Thanks, Rajan. So I will walk you through software templates and backstage. So all of us are aware of this famous quote, which is time is money. And do you really want your developers to spend time building the same old developing the same old boilerplate code every time they want to create a new application? No, right? So for this, and with the advent of microservices, every team has an autonomy to choose the solution which they like and which fits their purpose. For someone, it might be Java. For someone, it might be Node.js. So teams have got this independent decision on what they want to work on. But this creates a problem called as distributed fragmentation of developer tooling. Because someone might be working on Java, someone might be working on Node.js. So there is no common developer tooling. And the only way you can know how the developer tooling is set up is to speak with your colleague. So Backstage addresses this challenge with software templates or golden paths. Golden path is nothing but an opinionated and supported path for developing your applications. With golden paths, you can bootstrap your project ideas quickly by following standard practices like clean architecture. So golden paths are not meant to restrict or limit any developers. They are rather meant to be complementary to developers so that they can do what they do best, like develop applications. Golden paths also allow to automate the creation of GitLab CI/CD pipelines and deployment templates of OpenShift and Kubernetes. So on slide, I have included few links to golden path templates which are available from Backstage as well as Janus IDP. Janus IDP is an open source community supported by Red Hat. It's currently working on Backstage. So you can check out the golden path templates available on Backstage as well as Janus IDP. There are plenty of golden path templates available there, like clean architecture, React, Spring Boot with Helm chart deployment. Now coming to plugins. So Backstage has this customizable and extensible plugin architecture. In software systems, there is no one size that fits all. Every organization has its unique requirements, and it needs a unique solution for that. And Backstage is really built in a way that it is open for extension by default. And plugin provides a way to extend the Backstage architecture. So there are a number of plugins available on Spotify Marketplace. Also, there are some plugins which are provided by Red Hat, and the links to the same is provided in the slide, which is janusidp.io/plugins. So you can explore all the plugins here. Now, this slide shows an example internal developer architecture of an internal developer platform at an organization. It has variety of plugins like Circle CI for managing your continuous deployment, Service Catalog to manage all your services at a single place, Lighthouse for your UI application analytics. And it's not necessary that you should use a vendor provided plugin. In Backstage, it's very easy to develop your own plugin. So all of these plugins can be used as a mix and match of variety of plugins. And you can extend the Backstage architecture as per your use case. So I would like to cover this plugin of Motomo. Motomo is nothing but an open source web analytics platform. So we have developed this plugin in-house at Red Hat, and it will soon be available as part of community plugins in Janus IDP. Now we will like to go through a quick demo of Backstage.
So this is a Backstage homepage where you can enable, where you can do all the things right now here. So right now, first of all, I am going to show that how to do the software templating and how to bootstrap a software with a good golden paths and all. So for software templating is the core of the Backstage, where you can enable the developers to follow the best practices and everything. Let's see how we can create a software template. So we have defined a few software templates in our catalog right now. So I'm using the software templates for the with this Node.js backed application. So after you can add your organization, whatever you need. You can add your repository name, and you can who owns the system. Here comes the ownership of your code piece actually. So you can define the owner for a specific code which is going to bootstrap, and you can assign the system where it belongs to also. And you can modify the things however you want. So basically, it uses the YML format to declare your software catalog for your application. And you can define the actions which you need, which you follow. Once you do a create, we can see that software is getting cataloged in this specific group. So I'm doing a live publishing to the software in the catalog. So once you have done with it, you can see we can see a new repo has been created just now, which states that it is the code has been bootstrapped by the the Backstage. So similarly, also you will be able to track the software in the Backstage, which will give the life cycle. We can track the life cycle for this specific software piece from the day one. So this is how we can track the, and if you are trying to reconfigure this with someone else, you can also just update the catalog.yml, so you'll be able to track everything in the one place. Yeah. So this is one example of a software templating, and everything is managed within the catalog. Yeah. So this is one of the IDP which we use right now, HANAS IDP. HANAS IDP is something which we can utilize for building an IDP. So in the HANAS IDP showcase, this is a showcase app which is available publicly. It's available in showcase.hanasidp.io. So in the showcase, in the HANAS IDP, we have built a plugins for managing our infrastructure, managing our security insights, everything. So Red Hat has a very great community called HANAS. So they manage this right now. So this is a showcase application. I'm trying to show you the plugins which the HANAS IDP which has developed recently. So which is one is the majority is a topology plugin. Topology plugin is built on the top of the basic native Kubernetes integration on the Backstage. Backstage has a native Kubernetes integration. On top of that, the topology plugin has been built up. So you'll be able to get the insights of an infrastructure and in one place. For a developer, you don't need to go multiple places to see what is happening. If a pod is down, you can see that, like what is the status of the pod. Then you can take the action items necessarily. So another plugin is called the Tecton plugin. You will be able to see the Tecton pipelines over here. Another thing is image registry by the Quay. So you'll be able to see that like what is the image which you are using with the Backstage with your application. So you can see a track record of some image insights over here, and also some security insights. Yeah, at last, and also you can see how the system is depicted here actually. How a system is getting related to how a system is related to here. If you see that actually, if the showcase app is dependent on what all things. So you can define the dependencies, and you as a new developer, he or she will be able to understand like how the system works basically. That insights is basically shared. And if something is broken, so we can identify like where this problem can be where the problem is arised. And this is the documentation for the Backstage tech docs powered. So you can able to manage the documentation in one place right now. So with the documentation, you can manage the content over here, and this is a searchable piece of software. Even if you see here, you can search that actually. You can get the guides over here. So it is as much as extensible, Backstage. There is no limit for this extensibility we can get from this Backstage instance. Also, it is able to track the APIs. It can serve as your API catalog within your organization, so you can able to find like what all APIs which are getting used within your organization. You will get some insights on that right now. Yeah. 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 Cool. Yeah, I'm handing over to Adamania.
So currently, Janus IDP is an IDP provided by Red Hat. It is an open source one. There are also a lot of commercially available versions of IDPs, like Red Hat Developer Hub, which was recently announced at Red Hat Summit. This will soon be available in GA. There are also Amazon and Rodi who have built their own IDPs, and they are using Backstage as their central nervous system for managing these IDPs. Next one is, let's say you have decided to use Backstage as your internet developer platform, and you want to use your IDP, create your own IDP using Backstage. What should be the adoption plan? So first step would be trying out Backstage. To try out Backstage, you can use the demo applications which are available on Janus IDP, or you can use a demo application from Spotify as well. The next step would be POC, which would be you set up the Backstage instance on your local environment, and you try out, you try few configurations, like configure Backstage with GitHub or GitLab. The next step is building. Let's say there is some requirement for which Backstage is not providing the plugin, or you want to extend Backstage there, like we had for Matomo. So you can build your own plugins. So that is just a small feature where you just try out if Backstage is really working for you, and if it is the solution you are looking for. If it works for you, then the last step is spread the word, evangelize your adoption plan and extension. So we are welcoming contributors for Janus IDP. You can scan the QR code which is shown on the slide to join this Janus IDP Slack community. we are open for question and answers. Yes.
Can you onboard an existing project to Backstage?
Yes.
Yes.
Okay.
You have to just add a YML file, your software descriptor basically, in your existing project. Backstage is able to track from the things from the right away, that moment. Yeah. There is a VS Code extension is also available. I think that's created by the Spotify. With that extension, you will be able to create the template formatting. You don't need to worry about other technicalities. You can simply onboard the software with that.
Yes.
For me, it's obvious why it's beneficial for organization, but why it's beneficial for developers to contribute to Backstage.
So as a developer,
I'm sorry to step in. Can you
yeah,
repeat
sure.
the question for
Yeah.
the stream?
Sure. The question is how Backstage is beneficial for developers. So as a developer, you are a part of an organization, and like at Spotify, they have 1,000+ microservices. So, but it's shipped as a single product. So we, as a developers, we need to collaborate with multiple teams. Like front-end team needs to collaborate with back-end. Back-end team might need to collaborate with any another service. So every time you can't go looking for who is the owner for this application, what is their API, like are they providing any Swagger documentation. So for all of those things, Backstage is providing a single pane of glass, be it for developers, be it for managers, or for non-technical folks. I think there are no more.
If there are no any other questions in the backline.
Yes.
Okay.
So, would it be possible to, you mentioned about application templates, right? Like your algorithm tab.
Yes.
So, like one of the best practices of like if you're speaking about Kubernetes is like implementing maybe like readiness pros, requested limits. So I was wondering if is it possible to put checks inside those templates?
Yes. So
Okay,
you are
you
asking
can repeat
that,
the question.
you are asking that can we put the custom elements inside a code repository, right?
Yes, to make sure that whatever deployment you putting out there,
Yes.
those have like, is the deployment have readiness role? Does it have request and limit set?
Yes, this is completely flexible. So the things which is built on the Backstage is in the plugin concept. Even if you feel so like, so it is based on the plugin thing, it is completely customizable. For in the case of software template, you can set, ask for this check. This is a custom built form actually, based on the questions which you predefine in your the Kubernetes descriptor file, object descriptor files. It is a YML file. Yeah, so the references of this content of the slide and the things will be taken from the Backstage websites as well as the HANA IDP pages as the credits.
So, hi everyone. How are you guys? All set up with your evening coffee, I think? All charged up with that caffeine shot? Yeah. Okay, so my name is Arnav Bhati, and I'm a part of consulting services team based out in Germany. So we implement all these Red Hat enterprise products at the customer side. And my colleague Moritz, he couldn't join today's session because he's implementing AAP somewhere at the customer side, but his heart is in the session. And now I think let's begin with the agenda. So today, I would really want to keep this session and the slides very interactive with you all. And at the end of after this presentation, I would really like you all to go and play along with the demo which I've created for you. So you could install it on your local laptops, or you could just spin up 3 VMs on any cloud and then install AAP, play along with it. So today we'll be covering what exactly is a Ansible automation platform, some of the good practices and security implementation for your Ansible automation platform, as well as for the hosts which you are trying to automate. So we will be covering both the things. And then, of course, configuration as code, because code is important and you cannot do anything manual now. I have prepared a small basic demo, and I will try to show you some analytics around it. But before we move on to Ansible automation platform, are we all aware what exactly Ansible does? Yes, no, maybe? Perfect. Okay, so I would just say in our lives, automation is incorporated on a daily basis. Earlier we used to set up certain alarms, and now we have Alexa. Earlier we used to wipe and mop our houses on our own. Now we have robots who are doing it. Similarly, Ansible is an open source tool which would automate your entire infrastructure and your IT departments. And Ansible automation platform, it's a box of goodies which comes along with a set of toolkit which helps you to automate multiple tasks and resources together in your infrastructure team. So the first part is, let's say, for example, what exactly you would want to do with the operation side. You would have a UI, which would be provided by your automation controller, and your automation hub, which we are going to see later, but that contains your all execution environments, your collections, etc. To support that, we would need the Ansible content creation. So how are you going to create your Ansible playbooks? We have certain Ansible content creation tools, Ansible Builder, etc., through which you could create your execution environments, you could create your playbooks, test them, and whatnot. And finally, when you have all that in place, you would need to visualize what is running perfectly, what is failing, and you would need a beautiful analytical page to identify and to view all the stats. So that's what is all provided by this AAP platform. So now we are going to deep dive into some basics of controller, automation controller, which we just saw, and some of the objects of it. So automation controller, as you see, it's just a web UI based tool where you perform all the operations. So where you define all your playbooks, and it comes with a role based access mechanism. So whatever role to whatever object you would want to give, that's very easy. Second, it also has an API. So if you want to call an API to create something or to modify any object, that's also even possible. Plus, it's like if you want to see centralized auditing logs, who did what? That's really important in IT. Who messed up my environment? How can we resolve it? That's also even possible with this. And you could do a lot of things with this. I'm just covering some of the basics. Now, these projects, just imagine that you have a set of objects or building blocks which you would define in your automation controller. So your projects, let's say for example, if you have created Ansible playbooks and roles based on Git, you would just use an SCM extension to import all this code in your automation platform controller. That's just the building block. And if you see this image, especially this config as code, DevConf repository project code, we would be creating it in the demo as well. Inventories. So, for example, you want to start your own IT company, or you have your own startup. Now you would want to do certain tasks on your servers on which your application is running. Those particular servers would be added, or they are known as the inventory. So they are the actual hosts on which all this automation would be applied on. They are logically grouped, and again, it's all secure because you could define permissions, who can access your inventory. For this demo, we have again created another project based only on inventory. So let's say, for example, if I have 1,000 of hosts, which I want to automate, I need to group them logically. And I need to tell them, okay, my development environment has 50 hosts, my testing environment has 100 hosts, and so on. Then job templates. So job templates, I would call it as like, it's a glue, or it's again an object which has everything. So whatever project you define, or whatever playbooks, whatever execution environments, credentials, they all stick to this job template. And the best part is, it's reusable. So you create this job template once, it runs your playbook, and then you are done. So you could reuse this job template again and again for your multiple automation tasks. Workflows. So to make it simple, it's just the combination of all your job templates. So it looks like a pipeline, but it's not. It's a workflow template. So these are some of the basic terminologies which you use in Automation Controller. And trust me, by now, you're already one step closer to being an AP expert. So let's talk about some of the good practices and security implementation for this entire platform. And so to begin with, what exactly is wrong with this picture? Any guesses?
It's messy.
Exactly. And so when we start developing a lot of things, at a later stage, our code starts to get messy. But if we start with an organized way, or organized way of writing code, it's much more easier to understand, and it's much more easier to manage it. So that's one of the good practices, that you need to organize everything. You need to organize your roles, you need to organize your inventories, your playbooks in a proper way. That's the basic step, in my opinion, to implement a good practice in your team or in your organization. Another example is you need to create simple playbooks and inventories. So if you see, that's my playbook, and it's just a few roles which I've defined. I have not written any complex logic over here. I have not defined that it has to iterate or loop over certain rows to automate. I've just kept it simple. All the logic resides in the roles itself. Similarly, if you look at my inventory, I have managed and I have labeled it according to my environments. So all contains all of my hosts. My dev has my host 1. I have my prod with host team. And if I want to club them all, I have a child host which would contain my dev and test hosts. That's how you manage your inventories. Another important thing is like infra as code. We have heard about this term a lot. But when we go to customers and we see that it's still not implemented properly, the versioning of infrastructure as code is not done properly yet. That's where we feel like there's a huge scope where developers, where all the IT guys, operation guys need to collaborate together to build it properly. So in this example, if you see, let's assume you're an Ansible playbook developer or infra code developer. You would just do exactly same things as you do if you were a Java developer or if you were a Python developer. You would commit or create your Ansible playbook code in a development branch. You would use the best tool set which are available as VS Code extensions, ID extensions, or as anything else. And then you would just do a proper peer review, approve it, then that code gets run to your validation branch. You can call it testing branch, whatever. And then it gets merged to your exact production running system. Now, when we talk about security, integrating with LDAP-based systems, I think that's, again, a necessity. Because every enterprise we talk about, or any company, be it a startup or a medium-sized company, all of them, they're using certain LDAP mechanisms in their companies, or LDAP servers. And with automation platform, you can seamlessly integrate all of it. So we have done integrations for multiple companies, and it's pretty easy if it comes to automation platform. Then let's talk about, okay, any ideas viewing this, what are we talking about? It definitely doesn't have gold in it, so exactly. So this can be, you need to use vaults and credentials in your controller. You cannot just put on simple passwords in your Git repo. That's not recommended, and it's not a good practice at all. So what you do is you integrate with multiple enterprise vaults which are available in the market, or open source vault, that is up to you. And then you store all your secret data in those vaults. Automation controller connects to that vault to fetch the value. That's what, again, makes it more secure. And again, using vaults and secret management is one of our good practices if you're using Ansible automation platform. Okay, so this is the server hardening. So, okay, if you have worked on Linux, I'm pretty sure you must have hardened your servers, made a lot of changes in the services, default services, which comes with the RHEL server or Linux server, and you must have disabled the root login. You need to be always updated to all these packages, and you need to have SSL TLS certificates, auditing, etc. Now, a question to all of you. When we were doing all of these manually, or using certain shell scripts or any other additional tools, how much time it would take to set up all of these? Any wild guesses?
Long time.
Oh, long time is pretty long. But of course, yes. In the demo which we are going to have today, I would just automate all of this in the workflow which we just saw, and we would see how much time it took. Then one of the best practices which we're talking about, this is configuration as code. So to give you a brief example, I've created 3 repositories. My first repository is where all my Ansible code is present. It's like it has all my roles to disable the root login, update packages, etc. My second repository is the inventory, on which host all this job templates would actually run. And my third repository is my configuration as code, which would download my AAP, configure it as per my wishes, as per the best or good security practices, and then it would make all the automations which we have defined in the playbooks repo to all your hosts. By this approach, we are not just configuring our Ansible automation platform, but we are telling the Ansible automation platform that perform all these tasks on all my hosts. So it's all in one. And for this demo, I've used 2 organizations, org storage, org Unix. We have defined role-based access controls over here. So the teams which are over here, the storage admins and the storage developers. Storage admins have the admin access to all the objects which you see, which we just talked about. And the Unix, they have, the admins have all the accesses, developers have the execute permissions, and the operation teams can just use it. So they cannot modify or edit any of the current job template or any other project. So, well, that's my favorite line from Linus Torvalds, and we have seen a lot of presentations. Let's talk about code, how exactly it works. So, okay. So this is my Git repo, which is defining my automation controller. What you need is just 3 VMs. So on this laptop, what I did is I'm using a tool called as UTM, and I created 3 RHEL machines, one for my controller, one for my automation hub, and one for my DB. I've just installed plain RHEL on these 3 machines. There's nothing else. And when I run my playbook, which is called as install configure, this downloads the AAP from the Red Hat console, it installs it, and then it configures it. I need to define just my inventory file. This is my inventory. So the first part which you see over here, it asks for what automation controller host you have. So I've defined my controller host. I have defined my automation hub. These can be plain IPs of your local VMs if you're running it on your local machine. And then my database. That's all. Now, first 15 minutes. Now if you see, it already installed my automation platform. This is how it looks like. Okay, and the password is incorrect. So let me just grab the password. Okay, so that's my dashboard. This is all we were talking about. What exactly is automation controller? That's my dashboard, and these on the left-hand plane, if you see, these are all the resources which we discussed briefly. So we discussed about templates, credentials, projects. Now, by default, this controller has a lot of things which it comes on. So I can define certain settings. So by default, when you install an automation controller, you would see that there is a list of 100 modules which comes along with it, which includes shell and other things also. But when I was installing this, I changed this setting while installation. Over here, if you see this repository, all, this is like the generic settings or generic objects which I want in my automation controller. So over here, in my settings.yaml, I have just provided these two commands to make my automation platform more secure. I do not want a user to use an ad hoc command, shell, and then reach out to my machines and create some issues for me. Then I have whatever settings I want, which you see in my controller over here. These all can be configured via these playbooks or via these settings. It's all there. Then, if you see, I just have the basic users over here, admin and student, which comes by default. I want to create certain new users to it through my configuration code. And if you see over here, okay, that's running, let's delete it. Well, deleting it at the production is not a good practice, but let's see. Okay, so all is gone. And now, from my terminal, I would be running this particular command. Before running this, let me show you some more things. So, Ansible playbook, I have defined which vault to use. By default, whatever credentials I have used, I have vaulted them using the default Ansible vault, and all those vaulted values are stored in Git. So everything is secure. Then I am passing on my inventory to which inventory and which host it should connect to. I am passing my limit to dev environment, which we just saw in the inventory. And then the playbook name, it's going to ask me password because that password I used to create the vaulted files, and my environment variable. So as soon as I run it, now it would start creating everything from scratch. And if I just put a timer over here, okay, let's see. Let's see how much time it takes to create, and then we would come back to the controller. But up until now, did you guys understood some of the basic concepts of AAP? Any queries or any queries until now? Okay, cool. So now if you see, this gives me the logging. It tells me that, okay, it's adding the credential type. It's configuring my controller credentials. It's adding my credentials. And if I show you here, it has already started adding my credentials. So now I have all the credentials which are defined in my config code. I'm not doing anything manually over here. If I look at the projects, these are the SCM projects which got here, and they, if you see, they're still running. They would get their revision. And now it's adding inventory sources. So with this configuration code, you can literally do 100% of the things. you can define whatever you need. You could define your hosts, you could define your organizations, which we talked, org storage, org Unix. Then we saw teams, and all of it is present here. So in my all, I have my, okay, it's in my development environment. So that's my development environment. And this is how I've structured it, that I would need certain teams only which are a part of my development environment. I would need certain teams who are a part of production environment. So that's how you could separate or segregate this. So if you go and look at my dev environment, I have defined certain teams over here. So team Unix admin DevConf. So I have 4 teams defined over here. And now if you see, it has created them. It has not only created it, it has linked these teams to my organization also. That my first 2 teams are a part of storage organization. My another 2 teams are a part of Unix organization. Okay, this is finished. Let's look at our timer. So, 2 minutes, 23 seconds. And now, if I come here, this is the job templates we were talking about, that you could reuse them. And it had created a workflow template for me. So let me just show you. And, okay, this is running. It has created this entire set of rules for me, which I have defined in my workflows.yaml file. It has linked all these job templates, and the slide which we just saw, that you could have multiple job templates linked to each other as a workflow template, and then this is how it's working. So disabling the root passwords, updating all the packages. If I deep dive into it, so this is the first task. It's configuring my web server. This is configuring my services. This is disabling the root login. Let's look at the output. So output says, okay, these are a dummy tasks, but if you see at the output, it ran on my DevConf host, which I have defined in my inventory, and then it just displays a message as of now. But let me show you some more things. So, and this is how I have defined my workflow in my code. So I've put down my first job template, which has a success node, failure node. You can also have approval nodes over here. You could do a lot of things with the code itself. So within just 2 minutes and a few seconds, or let's say 3 minutes, I was able to harden my hosts by using this particular config code repository. Now that there's a third part. We talked about analytics in the beginning. So if you see over here, that's my analytics console, which is like console.redhat.com. It gives me a brief view of what job templates run, how many of them failed, if I'm saving some money, which is really important, by the way. So if I come here, look at my organization statistics, it loads something about the organizations, and then it tells you what all clusters I have. So you could get all of it over here. This is what Ansible Automation Platform is all about. You get everything in a single package. And now for you, if we go back to our slides, we talked about the analytics part. As next steps, I have provided all the links to this GitHub repo, which are available for you guys. I just want you to try it out. Play along with it. And give us your feedback. What do you think about it? That's all we need. This entire PDF is linked to the session. So if you want to download it, feel free to do that. And now it's time for Q&A. Any question, guys? Sure.
I'm just curious, from Ansible, when you start about these playbooks, you use specific Ansible playbooks or specific Ansible modules, or are you using the API from the Ansible Automation Platform? Configure all the automation platform, organization, users, project, templates.
Okay. So the question for the audience is how we are configuring this entire thing is there a module available in the market, right? So there is, okay, so there is a module which is available, controller module, and I can show that to you in the code also. So if you come here, and if you look at the playbooks over here, the playbook which we ran was controller config, to configure everything. So it uses the controller configuration module over here. So that's there.
So it's not necessary to use the API, just the modules already.
Yeah, but developers tend to use, sorry?
Model behind the scenes usually
Hmm.
Yeah, for sure.
Okay guys, any other questions?
Answer automation platform, is it running again on Kubernetes or OpenShift?
So,
Both of them probably, and or if there's some cloud solution, you can use it also on cloud basis.
okay. So the question is, where can we run Ansible automation platform, on Kubernetes or directly on RHEL VMs? You could either deploy it on your RHEL VMs. So I told you that I used UTM as my virtualization manager tool. And I just created VMs, RHEL 8 VMs, 8.6 VMs, and I installed it over there. I mean, I didn't install it. The configuration as code installed it. If you want Kubernetes, there is an operator which is available also, through which could install your AAP platform. So that's also possible.
Yeah, so there are some prerequisites that are already optimized.
For the Kubernetes installation?
Yeah, for the Kubernetes.
I need to check for the...
If we need to deploy Kubernetes or OpenShift by our own.
So on the OpenShift, if you are an OpenShift admin, and if you look at the operators, there should be an AP operator available over there, which you could install. But for the exact documentation, I think I can get back to you with that exact documentation link for this. Okay. Yep.
Is there a recommendation for the platform to use or a best practice, or is it just for the company to decide if they want to use OpenShift or local installations for the automation platform?
Okay. So the question is like if there is a recommended practice to install AAP. So AAP, the default recommendations, like the required ones are that it needs a RHEL server. And so it depends completely on the organization where you would want to install AAP. If you would say, okay, we need OpenShift, use that. If you say we need to install it on the VMs, go for it. So I think, okay, yeah.
So the only dependency is the operating system. You have to have the RHEL system. No, it's not possible to install the AAP in Debian or
Yeah.
Linux distribution, right?
Yeah, it needs RHEL system. I think no more questions, or okay. Then if there are no more questions, I would request you to let me know your constructive feedback on this and give it out a try. If you feel or if you need any assistance, feel free to ping me. I'm available on GChat or on LinkedIn. Feel free to do that. So that's it from my side, guys. Thank you for attending.
Hello everyone, thank you all very much for coming, and I really appreciate your navigation skills. It's not easy to get here. This place is like in the wilderness. So my name is Orel Mizan. I'm a senior software engineer at Red Hat, working on the OpenShift virtualization networking team. And today I want to present to you my little talk. My cluster is running, but does it actually work? So just to fill the audience, has any one of you ever tried to configure a Kubernetes cluster or administrate it? Well, about half of the attendees. So, as you know, it's not really easy to do it, and when you try to add more features to it and extend it using third-party libraries or components, it gets even complicated. And I want to show you how, using automation, we could verify that our cluster actually works as intended. So the agenda will be to display the problem, to talk about what the problem is, and to give a concrete example using networking capabilities, and talk about the advantages of using automation in order to achieve this verification, and to talk about what the solution that we wanted to bring, what are the requirements we want from it, what is a checkup, how do you configure it, and how do you execute it, and I'll give a little demo, maybe two if we'll have time, and to talk about existing checkups that we already have, and how you could write your own checkup to test whatever you need from your cluster, and the conclusions. So first of all, the problem. Sometimes you have special requirements from your cluster. Let's say it could be in the compute, networking, or storage domains. Sometimes you want to support dedicated hardware. And there are many, many moving parts, in Kubernetes, and if you put more add-ons to it, then it gets even more complicated. And so the configuration is not always straightforward, and it could be time-consuming. You need to dig hard into the documentation, sometimes even to the code itself. And there are like day one operation. When you deploy the cluster initially and you want to understand, does it actually do what we intended it to do? And you could also do day two operations like update it or change configuration during its life cycle, and some things could break. So how do you know that your cluster actually works? In this demonstration and in this talk, I'll be talking about KubeVirt. All you need to know about KubeVirt, this is a Kubernetes add-on that allows you to run virtual machines alongside containers on a Kubernetes cluster. And that's it. This is all you need to know. By the way, are you familiar with KubeVirt? Is anyone here uses it? Okay, so like 3 people. We have a booth near D105. Please come visit us. It's a very interesting project. So let's give a concrete example. We have a cluster with 2 worker nodes, and we have a very high-speed network using SRIOV that you don't need to understand what it means, but it's like a specialized hardware with a lot of components that supports its operation in order for it to work. And you want virtual machine 1 to be able to communicate over to virtual machine 2 through a switch. Everything is like dedicated hardware, everything is high-speed networking. So how do you do it? You can do it manually. You can just spin up 2 virtual machines and do a ping between them, or do some other program like iPerf to understand whether you have communication over this network or not. But it could be time-consuming, it could be error-prone, like human error-prone. And it could be also not reproducible. Today, you put one manifest. In a month, you will use another manifest, so it will not be the same. And it will probably not be portable between clusters. So what the advantages of automation is that it is fast. You don't need to think a lot. You just activate the automation and get what you want. It is reproducible today, and in a month, and in a year, it will do the same things. It's portable between clusters. You can use it on your cluster today and on your customer's client tomorrow, on your customer's cluster tomorrow, and it will be the same. And it also hides a lot of complexity. You don't need to be an expert on all of the subjects that the automation contains inside of it. And of course, it's less prone to human errors. So what is the solution we made? What was the requirements for it? We don't want to use any specialized client, only kubectl, and using just plain YAML files, not using any custom stuff. It should not leave any leftovers after it does its thing, like if we're testing communication, we are spinning up VMs, and we don't want to leave them after we have completed the checkup. And it should be deployable and usable by a user that is not the cluster administrator. So everyone with sufficient permissions could use it. And it could interact with existing objects in the cluster. So what is a checkup? A checkup is a Kubernetes application. It's a plain application that is used to verify that a cluster functionality actually works as intended. And as all Kubernetes applications, it needs two things. It needs a container image containing the business logic of the checkup, and it needs a service account and RBAC rules to permit it to do stuff with the Kubernetes API, like create stuff, delete objects, and so on and so forth. So how do you configure or execute this checkup? So the configuration is very simple. You use a config map. You put it's like a map of strings to strings. You say what keys you have and what values do they have. And this is the configuration. You take this configuration, you link it to a Kubernetes job. A job is like a wrapper over a plain pod. And you execute this job. This job does its magic. It ends. And your clusters stay clean. We'll see it in a minute in the demo. And after this checkup finishes, it writes its results to the same config map you've used in order to config it. So you can read the results, save them in the side for later investigation, or just remove it if you don't need it anymore. So this is the first checkup that we ever done. It is called the VM latency checkup. It was like our proof of concept. And what it does is you have a config map that you put all your configuration into it. Then you have a Kubernetes job that is mostly boilerplate. You don't need to touch almost anything there, except for the two environment variables that tell it where the config map is. And it spins up two virtual machines. We connect to one of the virtual machines' serial console. We ping the other virtual machine and test whether we have connectivity and test the latency. Of course, we could use in future checkups fancier tools, but for this proof of concept, ping was sufficient. After we are done with the checkup, we say that we have connectivity. We say that we have measured the latency between the two virtual machines. We delete the virtual machines. Everything is getting cleaned. The job is finished, and it writes the results to the config map. So this is how the configuration is done for these specific checkups. You can see that we are using keys because we cannot use CR for this checkup because we wanted that non-cluster admins could use it, and only cluster admins can deploy CRDs, custom resource definitions. So we had to use config maps. So the config maps has a specific structure to them. We have a timeout that says after how much time we decide to kill the checkup, if it lags or if it gets stuck. And we have the parameters. We have spec.param.some key, which you use to define the checkup itself. Here you can see that we use the network attachment definition. You don't need to know what it means, only that it is an object that already lives on your cluster and the checkup can interact with. And this is the checkup job example. You can ignore all the boilerplate. It doesn't matter. All we care about are these two environment variables that tell the checkup where the config map is located, on what namespace, and what is the config map's name. And after the checkup has completed its run, it writes the results to the same config map that we've specified earlier. You can see here that the checkup had succeeded and that are no failure reasons. All the rest are details when it started, all the measurements that it did, and so on and so forth, or what nodes did the virtual machine went to or scheduled to. And also you can see on a failure, if the checkup fails, you can see that you have a failure, and what is the reason for the failure. On this specific test case, the virtual machines could not communicate over the network, so it tells us that we have a connectivity issue. So the main processes of these checkups, this class of application, the first thing they do is fetch the user configuration from the config map. The second is doing all the setup. In this case, it spins up 2 virtual machines and wait for them to boot. Later we come to the checkup's body, the main part of the checkup, like the heart of the checkup. We connect using the serial console to one of the VMIs, and we input the ping command to the target VMI. And we try to check if there is connectivity between them. And the last step, or first to last step, is the teardown. After we have discovered that we have connectivity or doesn't have connectivity, we delete both of the VMIs and wait for them to be disposed. And the last step is reporting the results. So let's see a demo. Here you can see that we try to query for the network attachment definition. It's just an object living on the cluster that you don't need to understand what it does. It just represents a network in the cluster. Next thing we do is apply the RBAC permissions for the checkup, so it could do its magic, like create virtual machines, delete virtual machines, and connect to their serial consoles. Next, we configure the checkup using a plain YAML file. We tell it that we want to use a specific network attachment definition. We want it to do a specific checkup duration, and we apply it. Next, we define the checkup's job, which I've said earlier, it's all boilerplate. You don't need to change anything except for where the config map is located. Next, we apply it. And we wait for it to complete. You can use this command, wait, or you can just pull it, or you can just look at it at the evening when it ends. And here we get the results, and you can see that the checkup had succeeded with no failure reason, and all the rest of the status. After the checkup was completed, we can delete the checkup's job, we can delete the checkup's config map, and we can delete the RBAC rules if we don't need them anymore. But if you want to run the checkup again, you can do it, but just you don't need to delete the RBAC rules. And as you can see, we try to get the virtual machines, and we see that we don't have them because the checkup had spin them up and deleted them. Now our cluster stayed clean, and we got our results. We know that the cluster can run this specific workload on this specific network. So, existing checkups. We have currently 3 checkups in the works. The first one, the VM latency checkup, is the one that was just demoed. It's the most mature, but it is the proof of concept for us. We want to use the lesson learned from this checkup for other more advanced checkup. And the next checkup that we are currently working on is called the KubeVirt DPDK checkup. DPDK is some kind of network technology that uses kernel bypass to pass very high-speed network throughput. And in order to configure it, it takes a lot of knobs. You need to really understand what you are doing. And in the end, you want to say, OK, does it really work or not? So we use the VM latency checkup and the DPDK checkup, one after the other, to tell that this cluster can actually work with DPDK workloads. So this is our main focus for the moment, and we try to stabilize it and to make it productized. The last checkup that we have is the baby checkup. It's still in initial stages of development. It's called the KubeVirt real-time checkup. What it does is it makes sure that you can run real-time workloads on a KubeVirt cluster. You can run a real-time application, like some kind of machinery in a factory, and it makes sure that you can actually do it. This checkup is in very initial stages of development, and it will be ramped up in the next few months. What if you want to write a checkup of your own? We have the Kaiagnos project that holds all of these 3 checkups. It provides a Go library that helps you query the config maps and write to them the results. And it has the VM latency checkup as a reference that you can take and use to build your own. And also you don't need to use Go. You can just do it in whatever language that you feel comfortable with and could query the Kubernetes API. So, for conclusions, the cluster functionality should be checked when the cluster changes, whether it is from building the checkup on day 1 or building a cluster from day 1 or changing it on day 2. And using checkups could make this process faster, reproducible, and less prone to human error. So you're all welcome to the KubeVirt booth next to D105. We have Andrew Burden, which is our community manager there, and Peter Horacek, which manages the network team. You should come and pay us a visit. You are all welcome. Thank you very much. We have time for questions and another demo. If you want to start with the questions, if anyone has questions.
I do.
Yes, please.
I was just wondering why, is there any particular reason why are you using the config map when doing VM latency checkup instead of like the custom resource, the definition of own design?
Okay, so the question was, why are we using a config map instead of a CRD? As I've said during the initial part of the talk, we cannot use a CRD, a custom resource definition, because one of our requirements was for a non-cluster admin to be able to install and execute this checkup. And a non-admin user could not deploy a CRD, thus we cannot use a CR that is derived from this CRD.
Okay,
thank you for your question. Any other questions? Okay, so we have time for another demo of the DPDK checkup, the more beefy checkup. That what it does, it spins up a traffic generator pod, an application that knows how to generate a lot of traffic in a short amount of time, and it sends it over the network to another VMI that takes this data and transfers it back. It's like the VM latency checkup, but on steroids. So the configuration is pretty much the same. The logic is pretty much the same, but the actual business logic is much more complicated inside. But for the user, it's all the same. So we want to see that we have our network attachment definition, what the thing that gives us the configuration to use the network. We apply this config map. As you can see, it is precisely identical to the VM latency one, but with another image name, and that's it. It's pretty much the same. We apply it. We wait for it to end. Of course, this is not in real time. It takes several minutes for it to end. We get the results. And we see that we have 0 packet loss, which means that we can use this cluster for our DPDK workloads. We delete the job, we will delete the config map, we will delete the RBAC permissions, and keep our cluster nice and clean. Any other questions? Yes, please.
I noticed that the config map data has a structure similar to the Kubernetes descriptors. Was there a reason for it, or just for a convenience?
Okay, the question was why do the config map keys are similar to a regular object in Kubernetes. So the reason is to make it similar for people, that are using custom resources and using this. This is like a workaround. We cannot use custom resource definitions, so we are doing the next best thing, but on config maps. Thank you. Are there other questions? Okay, thank you very much. Thank you all for coming at this late hour.